Hello, hello, hello. Very good evening, all of you. How are you all? Hello, Narundariki. So, back with the new chapters, everybody. Hi, Spandana. Hello. All right. So, start check the Mandariki Chapandi Okasari. How is everything going on, Ra? So, Iroju, we are going to cover current electricity, one shot. Yes, great. So, I'll also try to include the PYQs also, Ray. Okay, so this session, we're going to start from the scratch. We're going to come up. Good morning, Raju. Very good morning. Sure. So, let us start with high energy, Ra. Sir, why are you spoiling our day, sir? It's a holiday. It's a New Year holiday, sir. Why are you taking the class? The only priority is NEET. Good morning. Other than that, no holiday, no New Year, no festival, sir. Only NEET till May. Dan tarvata you do whatever you want to do. Okay? Great. Okay. So, let us start, all of you. I want all of you to be very attentive. Okay? Before starting the lecture only, okay? Yeah. So, before starting the lecture only, I want you to sit with great energy. Okay? I want you to sit with energy plus hopes plus perseverance. Okay? Let us see. Everything could be adjusted, right? Everything. Okay? Good. So, sir, the name of the chapter is current electricity. Hey, do you remember something about electrostatics? Huh? We discussed about electrostatics. What do you remember about electrostatics? Chepo. Sir, field, electric field, electric potential. Yes. Great. Yes. Same applications. Okay? You understand? There is a link between the two chapters. A little link. Koncham. It is very low. Very less little. Yeah. Smiley. Good morning. Great. Sure. So, the electric potential that we see there, Gurdunda, if I have a charge ray plus Q charge at any random distance R, how will you write the potential? Potential is equals to K into Q divided by R. Same potential. Same. Here also, when we're talking about the potential in a circuit, and the similar potential is there. Good. Raju, very good. All right. So now, I want to start with a very basic chapter. Topic. Current. Choose kondira. Current ante enti re. Current ante enti. Sir, the current is rate of flow of charge. Adi kada? Yes, very good. Raju, very good. Current enti ante, current is the rate of flow of charge. Adi kada? Yes. So, for example, if you have Q charge, charge is Q and it is flowing in time T, time is T. Chappandi andariki. How will you write current? Sir, current is equals to Q upon T. Kani, sir, very rakalu unnai. Current lo, we do talk about instantaneous current, average current, total current. Ade kada? Right. Chuskondi andariki. You remember something about atomic structure? Yes. So let us start with a basic question. If 10 coulomb of charge is flowing through a given cross section, in 2 minutes, find the current. చెప్పండి అందరికి. Sir, charge is equals to 10 coulomb. అదే కదా. Time ఎంతరా? Time is 2 minutes. కానీ I don't write time in minutes. I write time in seconds. Seconds. Okay, 2 minutes అంటే 120 seconds. అదే కదా. Yes. చెప్పోరా. Sir, I is equals to Q by T. Total current flown by total charge flown by total time taken. Charge is 10 coulomb divided by 120 seconds. అదే కదా. Yes. చెప్పండి అందరికి. So it is 1 by 12 coulomb per second. Coulomb per second is ampere రా చూసుకోండి. అదే కదా. Yes. Hey, remember 1 ampere is a huge quantity, okay? Very huge quantity. Very good. Very good. Very good. Very good. Very good. So it is approximately equals to 0.08 ampere ra. Ade. This is my current. Next చెప్పండి. A charge of 2 coulomb is rotating in a circle of radius 7 meters with speed with speed should I take the speed 10 meter per second తీసుకో. ఓకే, జనరల్ వాల్యూస్ రా. 10 meter per second full stop. Find the current flown రా. చెప్పండి అందరికి. current flow లేదా ఓన్లీ కరెంట్ రే. టర్మినాలజీస్. ఫైండ్ ద కరెంట్. చెప్పండి. To complete one rotation, what is the time ra? Time is distance by speed, sir. Constant speed kada. Yes. So distance enta ra? Circumference formula enti ra? 2 pi r. Okay. Yes. Getting it re. Cheppu. Sir, current is equals to Q by T ra. Q value undi na daggara chuskondi. Q is how much? 2 coulomb ante kada. So 2 coulomb divided by time. It is a very difficult task to understand. Time and total distance divided by speed. Distance by speed ra ante 2 pi r by v ade kada. Yes, you can simply say, sir, substitute the values. 2 coulomb divided by 2 into pi value 22 by 7 తీసుకోండి into radius is 7 divided by time is 10 seconds kada. Speed is 10 meter per second, right? 7 gone. So that is equals to, you send this in the up direction. So it becomes 20 coulomb divided by, చెప్పండి, 44. 44, how much, right? Yeah. 44 seconds. Next, చెప్పండి అందరికి. So current is equals to, it's divisible by 4, right? So 4 5s are divided by 11 ampere ra. 5 by 11 ampere ante enti? Approximately equals to 0.4 ampere. Ade kada. So this is my current ra. Hey, a charged particle rotating around the circle. Are you remembering something? Electron ray. Hey? No, trying to be disciplined. నాకు ఏం తెలియదు ఆ గురించి. సో లెట్ మీ టాక్ టు ద టెక్నికల్ టీమ్స్ యాక్చువల్లీ. ఓకే, we don't. Okay, we can't do anything in that. Let us come to our question, right? If a charged particle is rotating around a circle ante nucleus is the center and electron is the charged particle ra. Formulas గుర్తుందా? అటామిక్ స్ట్రక్చర్ చాప్టర్ నుంచి రా. టైం పీరియడ్ ఆఫ్ ఫార్ములా అంటే టైం పీరియడ్ ఆఫ్ ఎలక్ట్రాన్ రా. స్పీడ్ ఆఫ్ ఎలక్ట్రాన్, రేడియస్ ఆఫ్ ఎలక్ట్రాన్ గుర్తుందా? సంథింగ్ రే, సంథింగ్ అంటే. Now I'm giving you the question. Find the current of electron in, should I take general value or particular value ra? In second orbit. Okay, in second shell of hydrogen atom. Adera, oh, finished. Leda, let us take a general scenario. Second, I don't want second shell. Nth shell. Cheppandi andariki. Nth shell. Remember it as a formula only. Cheppandi andariki. Sir. Sir, if you are talking about current, it should be charge by time. Charge of electron. Intara. Charge of electron. How much is the charge of electron? E, small e. So, sir, information is charge value, sir. Charge value ela ochindi. Charge is equals to E. 1.6 into 10 to the power minus 19 coulomb. Okay, everything has value, but I don't want you to substitute it. Okay, because it's just gonna get complicated. Ante kada, right? Cheppandi. Charge is E ray. What about time ra? Naku time kavali ade kada. Time is distance by speed ra. Distance how much ra? Distance ela calculate cheyali. Cheppandi andariki. Sir, distance is nothing but the circumference. Circumference of the orbit. Circumference 2 pi r. Okay, sir, distance is 2 pi r divided by speed is v ade kada. What about r, sir? R ante radius. Radius of orbit. Sir, nth shell of hydrogen atom. The formula was there, sir. What was the formula? Sir, I'm not able to understand, right? I'm not able to recall it, right? What was the formula? N square h square epsilon naught by pi m z square. That's the formula, sir. Radius r is equals to n square h square epsilon naught by pi m z square. Sir, what are you writing, sir? N ante number of shell. Nth shell kada. H is your Planck's constant. Epsilon naught, I don't know what is it. Something it is there in electrostatics chapter we studied. Okay, pi m mass of electron, z atomic number, hydrogen atom ante z becomes 1. E is the charge of electron, right? What about speed? Sir, speed is equals to, what is the formula for speed, sir? What is the formula for speed, sir? It is equals to z square by 2 epsilon naught n h. Right. We will be studying in modern physics. If you don't understand, if you don't remember the formulas from your chapter, then we will be studying. Okay. Pick, substitute ra, cheppu. Sir, time is equals to, cheppandi andariki. Tondarga, 2 pi r ante enti ra? 2 pi into r value cheppu. N square, h square, epsilon naught by pi m z square. Ade kada, divided by, cheppandi, z e square divided by 2 epsilon naught n into h. Sir, why are you doing so complicated work, sir? Pi gone ra. You send everything this side, everything that side. So I'm really simplifying this expression. Chooskondi andariki. So time is equals to, it is equals to 2 into n square h square epsilon naught into 2 epsilon naught n into h divided by, cheppandi, sir, m z e square into z e square, that is equals to 2 into 2 4 ra. It becomes n cube h cube epsilon naught square divided by m into z square e to the power 4. Ade kada, ide na time ra. This is my time. Next, you write this current I is equals to q by t. And q is charge of electron E divided by time entara. 4 n cube h cube epsilon naught square. Sir, 4 n cube h cube epsilon naught square divided by m into, cheppandi, z square e to the power 4 ra. Hey, all of you. Hey, students, choosko. It is remembering, okay? It's important. Value substitute chesina tarvata epsilon naught value 8.85 10 to the power. All these values, okay? All these values. You substitute values, pi value, mass of electron we have, charge of electron we have. Substitute chesina tarvata, you will get the value of radius r is equals to 0.529. 0.529 into n square by z. Ade kada. And similarly, speed also. You substitute, you'll get some ranges of values of speed. Ante kada. You remember this. It's a very important formulas. Okay. I'm taking deliberately. Kabatti you understand and remember the formulas at least. These are very important formulas. Andariki chooskondi. Radius of nth orbit of hydrogen atom. Hey, not hydrogen, any general hydrogen like atom. Bohr's model. Okay, so here you can simply say current is equals to, cheppandi, so it is m into z square into e to the power 5 divided by 4 into n square into h cube. Hey, n cube, h cube, epsilon naught square. Chuskondi. Hey, ఒక atom లో current of electron గురించి మాట్లాడాలంటే చూసుకోండి, current is directly proportional to atomic number square. Understanding? And current is, చెప్పండి, inversely proportional to atomic shell number whole cube, n cube. చూసుకోండి, directly proportional to z square, inversely proportional to n cube. లేదా if you want, you can combine the two results and say something like this: I is చెప్పండి directly proportional to z square by n cube. Ade, you remember this also, okay? You remember this also. It could directly be asked, okay? Okay, how many of you are listening? Nobody is listening. Okay, nobody is listening. Okay, great. Ade. So let us talk about current. చూసుకోండి, number 1, you have average current. చూసుకోండి అందరికి, you have average current. And number 2, you have instantaneous current. Andariki instantaneous current. What is the difference, sir? Em difference unnai, sir? Average current ante you talk about total charge flown divided by total time taken, ra. Okay, good, very good, Raju, very good. Ante you can simply say, sir, current average is equals to total charge flown divided by total time taken. Ade kada? Yes. Kani in instantaneous current you don't talk about that, sir. I is equals to dq by dt. Ade kada? Differentiate the charge with respect to time. That's it. You get your instantaneous current. This is the difference between average and instantaneous current. Chuskondi ra. Total charge ante and how much, rate? Sir, it is equals to integral I dt. Ade kada? Divided by total time is integral of dt. If you are remembering, good. If you don't remember the formula only, ra. This is my average current, this is my instantaneous current. Ade kada? Now we are going to see some questions based on this. Chuskondi. Number 1 ra, question teesko. If the charge varies with time as q is equals to 3t cube plus 4t square plus 5t full stop. Find the current at 4th second. Cheppandi andariki. Hey, ఏం కరెంట్ గురించి మాట్లాడుతున్నారా? వాట్ టైప్ ఆఫ్ కరెంట్ ఇస్ ఇట్, రే? ఇన్స్టంటేనియస్ ఆర్ యావరేజ్? ఇన్స్టంటేనియస్ కరెంట్, యావరేజ్ కరెంట్? అందరికి గుడ్, వెరీ గుడ్ రాజు, వెరీ గుడ్. So it is talking about instantaneous current. అదే కదా, current at 4th second రా. ఒక ఇన్స్టెంట్ లో కరెంట్ కావాలి, చూసుకోండి. 4th second, I want the current at 4th second అంటే instantaneous current రా. ఓకే, చెప్పండి. So instantaneous current value ఏంటిరా? Sir, I is equals to dq by dt. అదే కదా? Yes. చెప్పండి. So sir, I is equals to dq by dt అంటే d by dt of q. అదే కదా? Yes. That means d by dt of q value ఏంటిరా? Q value is 3t cube plus 40 to the power 4 plus 5t. అదే కదా? 40 square is there, right? I'm sorry. Hey, sorry. 40 square plus 5t. Okay, చెప్పండి differentiation. Sorry, directly equals to 90 squared plus 8t plus 5. అదే కదా? కానీ t is equals to 4 substitute చేయాలి. Right? Substitute 9 into 4 square అంటే 16 plus 8 into 4 plus 5 అదే కదా. So 16 into 9 how much, right? How much? Table గుర్తుందా sir? Tables, sir. Tables, right? Tables. Plus 32 plus 5 అదే కదా. Do it. Do it. చెప్పోరా. So sir, current is equals to అదే కదా. It's too much. It's too much. It's too much. Theoretically it's not practically not possible, but still we are doing it some assumptions. చూసుకోండి 144 plus 32 176 plus 5 181 ampere అదే. So this is my instantaneous current ra. Next question తీసుకోండి. Hey, remember the formulas also. Okay, now the current in a conductor varies as I is equals to 2t plus 3 full stop. Okay, find the average current from t is equals to 0 second to t is equals to 1 second. చెప్పండి అందరికి. So very easy question actually. Okay. Where is the bottle, right? చెప్పండి. Hey. Hey, are you getting it? Not getting it, Ray? Some nonsense is going on, Ray. Some nonsense. Hi, Kirtana, hi. Okay. చూద్దాం. I don't like this color. I don't like this color also, right? I don't like these colors at all, right? ఏం కలర్ తీయాలిరా? Okay, let us take this one. Not this one. This one. Not this one, right? Let us take this one. Not this one. Okay. So let us take this one, right? చూసుకోండి. Hey, it is very common color, right? So let us talk about this color. Yeah. Little unique color. చూసుకోండి రా. So sir, I is equals to total charge flown ra. Total charge flow. Charge flow formula ఏంటిరా? Sir, Q is equals to I into T లేదా it is integral I dt అదే కదా. Yes, so it is my total charge flown, right? Hey, this is my total charge flown ra. Sir, I is equals to total charge flown divided by total time అదే కదా. Yes, divided by total time, right? Hey, total charge flown formula చెప్పండి రా. So integral I dt divided by integral dt అదే కదా. Times t is equals to 0 to 1. Okay, t is equals to 0 to 1. Sir, t is equals to 0 to 1. T is equals to 0 to 1. Limits. అంటే integral substitute the value of current, students చెప్పండి. So it is 2t plus 3 into dt divided by integral dt 0 to 1. అదే కదా. Hey, dear students. Good. Prasad, very good. So integrate చేసిన తర్వాత you can simply say 2t integral is t squared రా. అదే కదా. t squared plus 3t divided by, I can directly say it is 1 రా. Time is 1, right? So 0 to 1. Put the value. Sir, 1 square plus 3 into 1 is 1 only. 3 into 1 is 3 only. So it is 4 ampere of current is The average current flown from t is equals to 0 to 1 seconds. Chuskoti. Okay, so this is the average current. This is the average current. This is the average current. Okay, finished, Ray. Hey, do you want to solve one more question? Teeskondi. Question is, if the current exact similar question. I'll see if there are some PYQs based on similar pattern. Okay, let me just give 5 minutes. Done. So, do it by yourself. Okay, if you're not doing it, okay, if you're not doing it, let it be a homework question. Okay, let it be a homework question. Next, hey, all of you focus at this. Okay, listen to me very carefully. Battery telusa. Battery ante enti telusa. So, electrochemistry, cell, galvanic cell, voltaic cell. Something was there, right? All of that. That's under battery only. Okay? So this is the battery. Choose code. In physics, this is the battery. Finished. Nothing more reactions. Okay? Nothing at all. Okay. So this is my resistance. This is my battery. So V is equals to 10 volt. Example. R is equals to 5 ohm. Cheppandi. Current is how much? What is the current? What is the current? Hey, are you gone mad, sir? What are you asking, sir? 10 by 5 into 2 ampere current is there. Okay. Understood. Direction enti. Direction enti ra. Sir, now you remember. Andariki, I'm telling you, the direction of the current, the direction of the current in a circuit is always starting from the positive terminal of the battery and terminating at the negative terminal of the battery. So this is the direction of current. Chuskondi. Kani, the direction of flow of electron is not this. Why? Because current is rate of flow of charge. Hey, current is rate of flow of charge. I is equals to dq by dt. Kani మా దగ్గర రెండు రకాల చార్జెస్ ఉన్నాయిరా. Positive charge, negative charge, right? And when you talk about I is equals to dq by dt, what charge are we taking? We are taking positive charge. Students, listen to me very carefully, okay? So when we talk about the current, we are considering the positive charge always, okay? Always. That is the reason why we are getting the direction of current flow in this direction. Ante the positive current is assumed to flow in this direction. But the practical problem ఏంటి అంటే positive charge does not flow అంతే కదా, ఎందుకంటే it is there in the nucleus of the atom, it does not flow. What flows, sir? Electrons do flow. ఏం electrons, sir? Free electrons, mobilized electrons అంతే కదా. Yes, so though electrons flow ray, and if your positive current is flowing towards this side, your negative current should flow in the opposite direction. So it is actually the flow of electron in a resistor. Understand everybody, okay? Understand, all of you. All of you. Okay. చూసుకోండిరా. So if this is my resistor, resistor ante enti sir? Resistor is a simple object that opposes the flow of charge through itself. చూసుకోండిరా. Hey, this is the resistor and I am attaching this resistor with a battery అందరికి. So ఇదే నా బ్యాటరీ రా. So this is my battery, all of you. Okay, observe it very carefully ra. Hey? Direction of current. Direction of current. Cheppandi. Direction of current. Direction of current ra. So it is flowing in this direction. Ade kada? Yes, something like this. This is the direction of flow of current ra. Hey, ade kada? Yes, yes. This is the direction of flow of current. Ante in this resistor, the current will be flowing in this direction. Current ante em charge ra? Positive charge. Positive charge. It's the imagination, hypothetical condition, hypothetical condition. Kani, when you talk about the real condition lo, electrons are flowing. Electrons do flow in the opposite direction as a positive charge. So actual flow of current, it is the flow of electrons and it is the flow of current. Okay, so this is the flow of current ra. Okay, remember the direction. Ante kada? Hey, understand? Okay, okay, good, good. Next. So now let us talk about the analogy of a resistor. Sir, analogy of resistor? Yes, chusko. Imagine this is my conductor. Every conductor can act as a resistor. Okay, chuskondi re. Hey, what did I say? What did I say? This is my resistor. Resistor ante metallic conductor. Metallic conductor. Resistor ante metallic conductor. Chuskondi. Hey, all of you, all of you. Now, sir, how many electrons are there? Depending upon the mass, depending upon the atoms, there will be number of electrons into it. Ade kada? So these are the electrons. Visible? Yes. So, sir, in this resistor, these are the electrons. Em chestunnorra? What are they doing? What are they doing? Hey? What are the electrons doing? They are not sitting ideally. 100% not sitting ideally. Mari em chestunnorra? They are moving here and there. Yeah? Yes, they are moving ray. Ante each and every electron is moving in a random direction. Chuskondi. I am telling you again. Hey, very careful, very careful. Hey? Each and every electron is moving into random direction, something like this. Ante kada? Yes. So this is the speed of a random electron. Very fast. Very fast. The speed is approximately equals to 10 to the power 5 meter per second. Okay. So this is the speed of the electron. Chuskondira. So in a neutral conductor ante take any metal object. Okay, take any metallic object. Deedlo you will find that each and every electron is moving with a very high speed. Very high speed. Ante telusa? Each and every electron is moving with very high speed. Sir, if the electron is moving with very high speed, why are you not getting current? Are you understanding? Why are we not getting current? And you understand, okay? Understand. The electron, point number 1, okay? Point number 1. When you talk about average speed of electron ray, chusko. Average speed of electron. So this was my electron in a conductor. Andariki chuskondi. So this was my electron inside a conductor. What did it do, right? It was here. It did all these oscillations. It hit here and there. It went all these positions and came back at the same point. It started from some point, went here and there, and after that it came to that original point. Ante displacement intara zero. Displacement zero unte speed intara average speed adi kuda zero. Yes, so average speed is zero, and at the same time the surface of the conductor will not let the electron come out of it. That is the reason why you don't get shock ray. Understanding? So this is a neutral conductor. Okay, this is a neutral conductor. Yes, Bhanu will be completing total chapter by today itself. So I don't care how much time it's taking, Ray. Okay? Our expected time is 1 to 1:30. I have one more session, work power energy at 2 p.m. right? Yes. So you are packed with me till 6 p.m. Ray. Okay. So sir, this was our neutral conductor. This was the neutral conductor, sir. Now I'm going to blow up your mind, okay? Choose command. And this is a conductor at some potential difference. చెప్పండి అందరికి పొటెన్షియల్ డిఫరెన్స్ అంటే ఏంటిరా? బ్యాటరీ కనెక్ట్ చేసుకోండి రే. అదే, so the conductor will come at a potential difference now. So this is the conductor and it is the battery that I connected. Ante kada? Yes. Now we'll talk about the speeds of electron in both the scenarios. Andariki. Ray. Chalo, great. So sir, in this process, a situation low, electron is moving at very high speeds. How much, sir? Millions of meter per second. Very high speed. In the neutral conductor. And you take a general scenario, it is hitting random directions. Ante kada? Yes. All the random directions it is hitting and then coming back at the same position. Started from here and came here only, ra. But when you come at the potential difference scenario, until this battery will try to push the electrons. Ade kada? Yes. So cheppandi, direction of current versus direction of flow of electrons. Andariki, direction of current versus direction of flow of electrons. Sir, current direction ante this will be the direction of the current from positive terminal to negative, and direction of flow of electrons, ra, it will be in the opposite direction. Ade kada? Yes. So direction of flow of electron will be in this direction. So choose koni andariki. It was some good color. Okay. So this was my general electron. Okay, this was my general electron, right? Okay. So this was my general electron. It hit some random positions. Ante kada? It hit some random positions, and after hitting, it came at this position. Hey, choose kondi ipudu. I want all of you to focus. Okay. So this was the initial position of the electron. This was the initial position. This is the final position. Ante kada? Hey, I'm zooming it again. Choose kondi. So this is the initial position. This is the final position. It did all the collisions. Dan tarvata it reached to some final position. Choose kondi. Displacement entara? Displacement enta? Sir, this is the displacement. Ade kada? Yes. How much time, sir? I don't know. But some time is there. Ante it has got displaced in some time. Ante it got velocity. It got drifted. Enduku drift, sir? Endukante this battery that is connected. This battery is pushing this electron. Understanding? You imagine it something like this. There is a wedding, ray. You are dancing in that wedding, okay? You are dancing into that wedding. Nobody is doing anything to you. Understanding? Now suddenly 4 or 5 people came and they are pushing you from back. Okay, you are dancing plus drifting. Ade kada? So you are dancing plus drifting, the same process. Electron is dancing, ray. It is dancing. And at the same time the battery is pushing it. So that means this is the drift. And the velocity with which it is getting that drift is known as drift velocity, Vd. Ade kada? It should be something like this, right? Okay. So this was a neutral conductor. This is the potential difference scenario. Okay. చూసుకోండి, దిస్ ఇస్ ద డ్రిఫ్ట్ వెలాసిటీ, అంతే కదా. నా ఇప్పుడు yes, Pawan Kumar, yes, if you know basics of physics, directly jump to high weightage. High weightage ante enti, rendu branches, mechanics, electrodynamics, modern physics. దాని తర్వాత you can cover to the small branches అంటే waves, heat. చెప్పురా, see, okay, compare. Sir, when the current was not flowing into it, and it was a neutral conductor, electron was having very high speeds. Very high speeds ante how much, right? Hey. Very high speeds ante speed is approximately equals to 10 to the power 6 meter per second. Ade kada. But here, when you come and talk, the drift velocity Vd, it is very small, right? Very small. Understanding? The drift velocity is very small, approximately equals to, sir, 10 to the power minus 3 meter per second. Are you understanding? And the electron is actually moving in the left side with a very small speed, sir, very small. Then the question is, there are kilometers of wires, right? Kilometers of wires to conduct electricity from one point to another point. Sir, if the electron is moving with a very slow speed, how is it coming from point A to point B? Again, question kada. Hey, the electron does not flow, re. Chuskondi, electron does not flow. Ante, if I have to bring a point electricity from point A to point B, ra, city A ante Vijayawada, city B ante Hyderabad, ra. Chuskondi. It is my Vijayawada, it is my Hyderabad. So there is this cable, ra. So that means the electron at one end, it is not going to flow all the way to Hyderabad. Understanding? There is a series of electrons. Series of electron ante there are continuously electrons present. Ante kada? Yes. So what they are doing? You move one, the effect will immediately be seen in the next electron. Ante kada? So that is alternating current, ra. Okay. So you move the electron back and forth, the effect will be seen, and the motion of electron is current. Only the movement of electron is current, ra. Not complete travel. We are not talking about the traveling of electron, not at all. We are only concerned about the motion of electron. Ade. Okay. Ante kada? Yes. Cheppandi. So this is the drift velocity. Drift velocity ante enti ra? Again I'm telling you, okay? Again I'm telling you very important things. Chuskondi. If you have a neutral conductor, electron is moving in general directions, random directions, but coming at the same point. Ante drift velocity is 0. Ante net velocity is 0, average velocity is 0. That is why you don't get any shock, ra. Ante kada? But when you are coming at a potential difference scenario, electron is getting pushed by the battery. It is getting pushed by the battery. So electron is actually moving here and there, and at the end it is drifting a little until it is settling at a little drift. So that velocity is known as drift velocity. It is very small. Ante kada? Right. So now let us talk about some random things, ra. Okay? Some random things. Chuskondi. If I am telling you 4 or 5 terminologies andariki, if you are not good with these terminologies, your calculations will not be good. Okay. Right. Chusko. Imagine this is my first electron. Andariki. T is my first electron. It is my second electron. Ade kada? Yes. Both are moving, right? Both are moving. Ante they will collide. Ade kada? Yes, they will collide. Now, what I want you to imagine is, chuskondi, I am connecting this with a battery. Battery of voltage V, right? Potential difference is V. Total length of the conductor is L. Andariki chuskondi. Ante kada? V ante potential. Battery. Potential formula, sir. KQ by R. In the beginning of the lecture I told. In the beginning of the lecture. Chuskondi. Sir, potential is KQ by R. What is electric field formula? KQ by R square. Ante, sir, can I simply say electric field is nothing but potential upon length? Remember formula number 1, ra. electric field is potential by length. Ante potential gradient is known as electric field. Chuskoni andariki. Ade kada? Okay? Yes. Electric field is nothing but potential upon length. This is my electric field inside the conductor. Point number 1 to be understood. Okay? Point number 1. Andariki cheppandi. Great, great, great. Now I want you to understand some terminologies. The first terminology is the distance between the two electrons ante lambda. Chuskondi. Lambda ante it is known as mean free path. Okay? Terminology number 1, lambda is known as mean free path. Ante electron has to cover this distance in order to hit the other electron. Ante do the collision. Ade kada? Yes. So mean free path. So this is lambda. Dan tarvata, sir, it is gonna take some time, right? Some time to collide. Yes, that is known as relaxation time. Chuskondi. It is represented by the letter tau. Tau, tau, tau. Tau ante relaxation time. Andariki. Tau is a relaxation time. Ade kada? Yes. Okay. Very electric field. E is sir electric field, sir. Yes, electric field formula entira. Formula gurtu pettukondi andariki. Dan tarvata I'm telling n chuskondi. N ante number of electrons chuskondi. N is number of electrons per unit volume. Ade kada? Per unit volume ante in 1 meter cube or in 1 unit cube of volume, there are n electrons. Hey, chuskondi. In 1 unit cube of volume, there are n electrons. In 2 unit cube, 2n electrons. In 4 unit cube, 4n electrons. Ade kada? Right, you remember now, okay? So from here, when you talk about number of electrons, chuskondi. Number of electrons is equals to n ante number of electrons per unit volume multiplied by volume. Ade kada? This will be useful, all of you. Observe it very carefully, okay? This is number of electron. Charge of electron is E. I'm not writing, okay? I'm not writing here. Okay. With that being said, I will now take you to the trip. So trip ki welcome. Chuskondi. So this is a conductor, but it's not perfect trip. It's not perfect. Okay, so this is my first electron. Idena second electron. Ade kada? Right. Cheppandi terminologies. Sirji, lambda ante mean free path. Sir, E is the charge of electron, sir. E is the charge of electron, sir. E is the charge of electron. E conductor lo there is electric field. Okay? E conductor lo there is electric field. Sir, what are you talking, sir? Electric field in the conductor. But electrostatics chapter lo we understood that in the properties of conductor only. Electrostatics lo we said there is no electric field inside the conductor. And here I am saying there is electric field inside the conductor. Hey, what is happening, Ray? Huh? Chappo. We are talking in electrostatics. There is no electric field in the conductor. But I am telling here there is electric field. You don't know it. Okay. I also don't know it. Leave it. Okay? Electric field in the conductor is only zero when there is electrostatic equilibrium. Until there is no flow of charge. But here we are attaching this conductor with a battery. So due to this battery, let me change the polarity. Okay, so this is the polarity. For ease purpose. So when I am attaching the battery, the charge is flowing. No equilibrium. Until the electric field will not be zero in this scenario. Okay? Great. Cheppandi andariki. Lambda is the mean free path. E is the charge of electron. Tau is the relaxation time. Ade kada? Electric field inside the conductor is E. Chuskondi andariki. E ante na electric field ra. Okay? Sir, force on charge, sir. Sir, force on charge, sir, in terms of electric field. Sir, electric field is nothing but, chuskondi, electric field is nothing but force per unit charge. Yes, force per electrostatics. Okay? Electrostatics. Sir, electric field is nothing but force per unit charge. అంటే force is equals to charge into electric field. అదే కదా? Yes. ఈ సిచ్యువేషన్ లో చెప్పరా, what is charge? E into E. అదే. So this is my force. అందరికి చూసుకోండి. This is the force on electron రా. That is the force on the electron. చెప్పండి అందరికి. So the force on the electron is given by E into E. అదే కదా? Right. Very good. Very good. Very good. Okay. What about acceleration, sir? Acceleration is equals to force by mass, sir. And force is E into E divided by mass is M. So ఇదే నా ఎలక్ట్రాన్ కి acceleration రా, చూసుకోండి. అంతే కదా? Yes. So this is the acceleration. అంటే this is the distance, this is the acceleration. Relaxation time is tau రా. చెప్పు, initial speed 0 తీసుకోండి. Sir, S is equals to ut plus half et squared. S is equals to ut plus half et squared, sir. S is equals to ut plus half at squared. U అంటే ఇనిషియల్ స్పీడ్ 0 తీసుకోండి రా. అదే కదా? ఎస్. S అంటే డిస్టెన్స్ రే. డిస్టెన్స్ అంటే మీన్ ఫ్రీ పాత్ లాంబ్డా. హాఫ్ ఇంటూ యాక్సిలరేషన్ వాల్యూ చెప్పురా. యాక్సిలరేషన్ ఇస్ E into E divided by M into t square అంటే tau square. అదే కదా? So this is the formula for the mean free path of the electron. Half E by M into tau square. Okay? Great. Great. Now let us talk about few more things ra. Chuskondi andariki. But I want all of you to remember the formulas, okay? Wherever I am getting formulas, I am making rounds to them, okay? Okay, you understand? This is my formula, formula number 1. This is my formula number 2. I want all of you to remember these formulas, okay? If possible, make a separate note, andariki. Next. Chuskondi, this is my conductor, ade kada? Yes. So if this is the conductor, sir, electrons are moving in random direction, sir. Ante kada? Yes. So this was the first electron. It is moving some random direction, something like this. Complete motion IP tarvata, it is coming at some this point, right? And drift. Tell us this distance, extra distance drift. And we are telling that this distance by time is nothing but drift velocity. Ade kada? We are telling this distance by time is nothing but drift velocity. Sir, drift velocity. Let us talk about drift velocity in other terms, sir. So imagine, this is the battery. Ante kada? Yes. So the current flows like this, electron flows like this. Electron is flowing like this. Chuskondi. Sir, drift velocity V is equals to U plus AT. Ade kada? Again, I am starting from the initial point, right? Initial point ante speed is 0. Initial speed 0 ante V is equals to A into T. Sir, what is A, sir? A is the acceleration of electron. Sir, A is the acceleration of electron. E by M. Right. So, sir, V is equals to E into E divided by M into T is relaxation time, tau. Ade. So, this is my drift velocity, VD ante drift velocity. Ante kada? Yes. So one more formula you got, malli oka formula gurtu pettukondi. Very important anta understanding. So you rearrange this formula. Drift velocity is equals to E into tau by M into E. E ante electric field andariki chuskondi. This is the electric field inside the conductor. All of you understand, okay? Understand it. There is another. Okay, చెప్పండి. So, sir, this is drift velocity, this is E. Now this terminology, idigo, here. Sir, it is known as mobility of electron. Mobility of electron represented by mu. Ante drift velocity is equals to mu into E. E is the electric field where mu value is equals to E into tau divided by M. It is known as mobility of the conductor. Ade kada? Right. Next. Hey, are you understanding all this? Right. So, let us talk about one more scenario. Andariki చూసుకోండిరా. Again, this is my same conductor. Okay, again I'm telling you the same things. Malli all these times ra. But there is nothing. Okay, everything is same. చూసుకోండి. Right, very good. Very good, Prasad, very good. Very good. Okay. Now, what I'm doing is I'm going to consider a very small thickness ra. So you just imagine this much part of it. Okay? It should be something very thin ra, very thin. Okay, can you visualize this, Ray? Can you visualize this volume? So, a length ni I'm calling it as dx ra andariki, and this area is A. Area ante this total area of the face. What is volume ra? What is volume? Volume formula cheppu sir. Volume is area into height. Area into length. Area into length. Ade volume is equals to, sir, small volume ante dv, it is equals to cheppandi andariki area into dx. Ade kada, area into dx. Area into dx. Area into dx. Area into dx. Yes, yes. So this is the small volume ray. Now I want you to bring it to the terminology section. Chusko. N ante enti? Number of electrons per unit volume. Number of electrons per unit volume. Ante number of electrons is equals to N into volume ra. N ante number of electrons per unit volume. That is fixed for a given conductor. Okay? That is fixed. So you can simply say number of electrons is equals to N into volume ra. Number of electrons is equals to N into volume ra. So sir, number of electron is equals to N into volume. Ante N multiplied by volume cheppandi ra. A into dx. Ade kada. So these are my number of electrons in this volume. In this volume ray, ee volume lo unnadi electrons is this much. Na into dx. Sir, each electron has some charge kada. What is the charge ray? E. One electron, E charge. Two electrons, 2E charge. Three electrons, 3E charge. This much electrons, this much into E charge. Ade kada. Total charge. Cheppandi. So sir, total charge is equals to, cheppora, total charge is equals to Na dx into E. Ade kada? Yes. So this is my total charge. Cheppandi. Are you understanding? Now, this total charge is flowing from one end to other end ray. It is flowing kada. I've connected it to potential difference andariki. Chuskondi. Right? Terminology reversed. Terminology reversed. Small, big, like this. Okay? So the total electrons, they are flowing from one end to another end. So if they are flowing, ante current, sir, I is equals to flow of charge per time ante dq divided by dt. Total charge is dq or small charge. Cheppandi, it is n into a into dx divided by dt. Ade kada. Dx by dt re. Dx by dt. Small change in the distance divided by time. Drift velocity. Drift velocity. Right. Sir, I is equals to n e a v d. Ade. So this is the formula for the current ra. Okay. Current is equals to NEABD. Yeah? You can remember it this way also. Andariki cheppandi, sir, current is equals to drift velocity into charge of electron into number of free electrons per unit volume into area. Okay? So you can say V na. Okay? V na. I is equals to V na. Okay, good. What are you saying in the comments? Right. So now let me just collect all the formulas at a given point. Okay. Hi, Siva. Hi. Okay. Welcome, Siva. Welcome. Very, very warm welcome. Okay. చూసుకోండి. So now what I'm doing is ఇప్పుడు I'm going to write all the formulas at one place ra. Okay, all the formulas at one place. చూసుకోండి. Formula number 1 అందరికి formula number 1 I is equals to dq by dt అదే కదా. Yes, లేదా average current is equals to చెప్పండి అందరికి it is equals to integral I dt divided by integral dt రా. ఓకే, కరెంట్ ఇస్తే you apply average current formula, values పెట్టుకోండి and you calculate the current, అదే కదా. రైట్, దాని తర్వాత we talked about second formula చెప్పండి. we talked about drift velocity. How much sir? e into ఇదేనా drift velocity, లేదా you can also say vd is equals to చెప్పండి అందరికి so e into tau divided by m into e. right, perfect. Number 3 రా, ఇదే ఈ టర్మ్ ని I'm calling it as mobility is mu రా. mu is equals to e into tau divided by m. mu అంటే mobility. సో ఇప్పుడు the mobility అంటే how fast the electrons are able to move, అదే కదా. రైట్, నెక్స్ట్ we talked about mean free path ra. Lambda is equals to half e by m into tau square. దాని తర్వాత we immediately discuss the formula for current ray. Current is equals to drift velocity into charge of electron into number of free electrons per unit volume into area రా. చూసుకోండి. So these are my formulas అందరికి. I hope you understood these 5 formulas. Oh yeah, 5 formulas. Very good Prasad, very good. Now I want you to discuss some other terminologies with me ra. చూసుకోండి. Let us talk about current density. Hey, let us reserve this page only for formulas kada. Right, so let us take on another page ra. చెప్పండి. current density అందరికి current density is the current divided by area ra. అదే కదా. yes, very good. Okay, so let us imagine నా దగ్గర ఒక కండక్టర్ ఉంటే this is the cross section of that conductor అందరికి. right, yes. now I'm telling sir from this conductor the current is flowing something like this I, అదే కదా. yes. so let us take an area ra. మొదటిగా ఇదే తీరా నేను ఐఎమ్ కన్సిడరింగ్ దిస్ ఏరియా. ఏరియా ఇస్ ఏ. చెప్పండి సార్ కరెంట్ డెన్సిటీ ఇస్ డిఫైన్డ్ బై ద లెటర్ జే. జే ఇస్ ఈక్వల్స్ టు, జే అంటే కరెంట్ డెన్సిటీ, ఇట్ ఈస్ ఈక్వల్స్ టు సార్ కరెంట్ డివైడెడ్ బై ఏరియా. సార్ వాట్ ఈస్ ద ప్రాపర్టీ ఆఫ్ ఏరియా రే? వాట్ ఈస్ ద ప్రాపర్టీ అంటే యూ అండర్స్టాండ్. ఇన్ వన్ సినారియో ఐఎమ్ టేకింగ్ దిస్ కేస్ అండ్ ఇన్ అనదర్ సినారియో I am taking the another case. చూసుకోండి. Can I copy it ra? Can I copy it? Ra? I think I should control this. Yeah, let it be. Let it be. I'll shift it like this. Let us do one. Shift everything this side. Okay, right. So now let us take the same cross section area. Same cross section area. Same current ra. Hey, చూసుకోండి అందరికి. Okay, this is my area. ఇప్పుడు now I'm considering the area something like this ra. చూసుకోండి. So this is my area. I'm cutting it like this ra. Okay, this is my area and the current is flowing something like this. So this is my current ra. I. Area is A. Kani the area direction is this and making an angle of theta with the horizontal. Cheppandi. What should I rate the value of J in this scenario ra? J value em ravali. What should I write? What should I write? What should I write the value of J? J ante current density andariki cheppandi. So sir, simply write J is equals to current by area. Same area ra. Same area A. Ledu. The area that is perpendicular. The area that is perpendicular to the current ray. The area that is perpendicular to the current ray. Teeskondi. This area has two components. Rendu components unnai ra. This is my main area kada. The first component will be vertically down. The second component will be towards the right. Eppudu draw the planes ra. Eppudu draw the planes that are perpendicular to these two components. Ante the first plane will look something like this. Hey. So this is my first plane, component of that area. The second plane looks something like this ra. Chuskondi. Ante kada. So I want only this area ra. Ante it is my total area A. This becomes A cos theta, ade kada, right? This becomes A sin theta ra. But I want current divided by the area component that is in the direction of the current. Ante the area plane which is perpendicular to the direction of current, leda area direction which is in the direction of the current. Okay? Very good. I divided by A cos theta, right? Very good. Right. Perfect. Now I want you to understand something, okay? Now I want you to understand something. J is equals to I divided by area kada. Yes. Very important topic. From here I am directly jumping to Ohm's law, okay? From here I am directly jumping to Ohm's law. Chuskondi. Very good. Prasad, very good. So now area formula entira Vena. VENA. Ade. Right. So drift velocity into E into N into A divided by area. Ade. A gone re. Cancel. So what is left? Sir, J is equals to drift velocity into E into N. Ade. Hey. Drift velocity formula entira. Drift velocity formula gurtunda. Understanding anything. Sometimes it's getting true or sometimes it's getting too far. Okay. Drift velocity formula entira. Drift velocity formula. Sir, drift velocity formula. V is equals to U plus 80 ante E by M. It is air divided into time. Ade kada? Yes. So ikkada nunchi simply say, sir, E into tau divided by M into E. It is my drift velocity formula. Hey, చూసుకోండి రా. Lift, shift. చెప్పండి. J is equals to E into tau divided by M multiplied by E into N. అదే కదా? Right. So you get E squared. చెప్పండి. Hey? Right. E is there. E is also there. So E square tau N divided by M into E. ఇదేనా J కదా? చెప్పండి. Right. Good. Very good. Okay. So this is my current density ra, J bar. This is my electric field E bar. Ade kada? I want you to remember all the formulas re. So I'm not understanding like if to give all these at one single place or very good. Prasad, very good. So let us do one thing. Let us make a cross section only. Choose. Tell me the formula once again. Cheppandi. J is equals to E square tau N by M into E bar. Ade kada? So from here you send everything that side. Cheppandi. So you get E bar is equals to M divided by E square into tau into N into J bar. Ade kada? Very important. Hey students, it's a very important formula. Okay, remember this. Okay, very important formula. Now, this terminology we call it as rho. Rho ante enti sir? Resistivity. You remember this in mind. Okay, rho ante resistivity ra. Okay, rho ante resistivity andariki. Okay, right. So this is the resistivity formula. So that means now I'll take on a fresh page. Andariki chuskondi. So sir, E bar is equals to rho into J bar. You keep it as a milestone for your mind, okay, in your mind, right? It is the differential form of Ohm's law. Ante enti sir? Differential form, huh? Yes, differential form. Ante now we are going to integrate, do some sort of stuff, and then we are going to say, and we are going to see the things, right? Sir, E ante dV by dx. Field, right? Electric field formula, gurtunda, electrostatics nunchi. E is equals to V by L. Ante here, when you are talking about the conductor, చూసుకోండి అందరికి. So this is your electric field kada. Hey, చూసుకోండి. Here the potential has been applied. Okay, this is the potential that has been applied. So this is my electron అందరికి చూసుకోండి. So this is my electron. Electric field is there, but you take, it is V volt battery kada. Length is L అందరికి చెప్పండి. Length is L. Length is L ra. L. Voltage is V. Ante over the total length, the potential is V. Ante if you are considering the potential here to be 0, automatically the potential will become V here. Understand? I'm telling you, okay? For the students who understand this, understand. Total potential gradient or difference is V and the total length is L. But you talk about very small length, ra. Very small length. So let us say this length is DL. Andariki చూసుకోండి. Length DL kada? Yes. What is the potential difference, re? dV. Small potential difference dV for this DL length, ra. Ade same thing. It is known as electric field. E ante dV by DL is equals to చెప్పండి rho into J. J is current density. Sir, J is I by area. Yes, J is I by area, re. J is I by area. Ante dV divided by DL is equals to rho by A into I. Ade kada? Yes, right. Sir, let us do one thing. Let us send this DL to the right side. dV is equals to rho by A into I into DL. Ade kada? Ippudu integrate cheyandi ra. So this was for small length DL. Such small DL, they are there from 0 to L. Ade kada? So the limit of DL changes from 0 to L. At the same time, the limit of potential changes from 0 to V ra. 0 to V. Ante 0 to V. Ade. So you can simply say, sir, upper limit minus lower limit ante V is equals to చెప్పండి rho constant, A area constant, I current constant. Take them out. So rho by A into I integral DL 0 to L. Ante you can simply say V is equals to rho by A into I into L. Ante V is equals to rho L by A into I. This is my Ohm's law. Okay, this is my Ohm's law. Cheppandi. Sir, we got V is equals to rho L by A into I. Rho formula enti ra? We calculated the formula for rho kada. Rho చూసుకోండి M by N E square tau ra. M by N E square tau అందరికి. So V is equals to rho formula. M ante mass of electron by N E square charge divided into tau. Tau is time, relaxation time, multiplied by length L divided by area A into current I. So sir, V is equals to ML divided by N E square tau A into I. Ade kada? This మొత్తం quantity we are calling it as R. R ante resistance. Andariki చూడండి. R ante what? R is the resistance. So here, ekkada nunchi I can simply write, sir, V is equals to R into I. Ante V is equals to IR. Ade. So this is my Ohm's law. ఈ ఫార్ములాలో you must be good at the value of resistance ra. No other option. అంతే కదా? This is the value of resistance. Resistance value enti ra? Resistance value is, again I'm telling you, okay, again I'm telling you, it is very difficult for me to keep the track of your brain ra on the syllabus. Okay, very good, Prasad, very good, perfect. Okay, perfect. So you can simply say, sir, V is equals to I into R. It is Ohm's law. Kani the value of R is equals to చెప్పండి, R is ML by NE square tau A. Sir, ML divided by NE square tau into A. Ade kada? Multiplied by, not I ra, it is not, this one. And this quantity ra, this quantity, We call it resistivity. Gurdunda? Yes, sir. R is equals to rho L by A. This is my second formula. So they are the formulas I want you to remember till now. Okay, so let us do one thing. Let us take our formula sheet and add these formulas also. Cheppu. So this was my formula sheet kada. Fifth formula. Formula number 6. Cheppu. Sir, current density J is equals to I by A. Ade kada? Right. Dan tarvata we simply said చెప్పు సెవెంత్ ఫార్ములా సార్ ఈ బార్ అంటే ఎలక్ట్రిక్ ఫీల్డ్ ఇస్ ఈక్వల్స్ టు చెప్పురా రో ఇంటూ జే బార్ అదే కదా ఎస్ రో అంటే ఏంటిరా ఎయిత్ ఫార్ములా సార్ రో ఇస్ రెసిస్టివిటీ ఫార్ములా ఏంటిరా రెసిస్టివిటీకి సార్ రో ఇస్ ఈక్వల్స్ టు ఎమ్ డివైడెడ్ బై ఎన్ ఈ స్క్వేర్ టౌ అదే కదా ఎస్ దీస్ ఆర్ ద ఫార్ములాస్ దట్ ఐఎమ్ టెలింగ్ యూ ఓకే దీస్ ఆర్ ద ఫార్ములాస్ దట్ ఆర్ జనరేటెడ్ సో ఫార్ రా అందరికి చూడండి నైన్త్ ఫార్ములా రా చెప్పండి సార్ V is equals to I into R అంటే R is equals to rho into L by A. L అంటే length of the conductor, A అంటే area of the conductor, or R is equals to చెప్పండి సో ML divided by N E square tau into area A. ఇదేనా వాల్యూ ఆఫ్ రెసిస్టెన్స్. ఒక గివెన్ కండక్టర్ కోసం మాస్ ఆఫ్ ద ఎలక్ట్రాన్ is always fixed, N is always fixed, E square tau they are always fixed. What is variable? Sir, length and area. Ante entira? Ante, let us go to the main slide. Okay, these are the formula slides. Andariki. Okay, so I'll add one more slide in it so that we collect all the formulas. We keep collecting all the formulas. Okay, okay, చూసుకోండి. So, sir, the formula is resistance is equals to rho into L by A. అదే కదా. So, నా దగ్గర 2 resistors ఉన్నాయిరా. Take a question. Find the ratio of resistances. R1 by R2, okay? R1 is to R2. Now, this ratio kavali ra teeskondi. This is my first resistor. Okay? R1. Okay? Length is L1. L1 అంటే L తీసుకోరా L1 అంటే L okay area is A రా అందరికి చూసుకోండి ఇది area A. This is my second resistor. Okay, let us not give the area, I will rather give you the radius ra. Radius is R. Okay, radius is R ra తీసుకోండి. Here the radius is 2R. Okay, the radius is 2R and the length is 12. Ratio చెప్పండి resistance is R2. Okay, I'll be back in 2 minutes. 2-3 minutes, not exactly. Okay, getting it, not getting it right. చెప్పండి. Okay, so refreshed. There, I want that only, okay? Madhu Yadav. Okay, 2 times Madhu Yadav. I want R1 by R2 only. So, sir, resistivity is same, okay? Let us take something like this. Same material. Material same ante resistivity same, okay? Material same ante resistivity same. Now you tell me, sir, R1 by R2. Hey, R1 formula cheppura. R1 is rho L1 by A1 ade kada divided by rho L2 by A2 ra. Oh, nice. Ante rho gone. Sir, it is equals to L1 A2 divided by L2 A1. L1 value L ra. A2 చెప్పు. A2 అంటే it's a circle. So cross sectional area of circle is pi r square. Okay. Cross sectional of area is pi r square ra. అంటే L into pi into R2. R2 is 2R divided by L2. L2 is 2L right? Multiplied by pi into చెప్పండి R1 is R only. అదే కదా సార్. LL gone, pi gone, R square gone. So it is 4 by 2 and 2 by 1. Adhe. So R1 by R2 is 2 by 1 ra. Chuskondi. Okay. Okay. So let us discuss few more questions, ra. ఇదిగో నా length L, area A ra. Okay, immediately, okay, resistivity rho. Okay, resistivity rho. Immediately to this metal I am attaching one more resistance. చూసుకోండి. So it is my second resistance. So now area is same ra. Area is A. కానీ I am changing the length. So let us say this length is 4L and the resistivity is 2 rho. Cheppandi. So when I take the total material and mix it and form a new resistor, what will be the resistivity of that ra? Okay. Cheppandi. What will be the new resistivity of the material? Hey, I forgot the bottle. Hey, you do it, I'll be back. Okay, I'll be back. Every time same thing is happening. చెప్పండి. సో 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 ఏం మాట్లాడుతున్నావురా? వాట్ ఈస్ గోయింగ్ ఆన్ ఇన్ ద చాట్ బాక్స్? Hey, replace it, Ray. You replace it with another conductor, but the dimension should be the same. అంటే టోటల్ ఎంత ఎంతరా? 5L కదా, ఇక్కడ 4L, here is L, టోటల్ 5L, ఏరియా అంటే A. సో యూ రీప్లేస్ ఇట్ రా, యూ రీప్లేస్ ఇట్ వన్ మోర్ రెసిస్టర్ అంటే కండక్టర్. ఎవ్రీ కండక్టర్ ఈజ్ అ రెసిస్టర్ సార్, అండ్ ఎవ్రీ రెసిస్టర్ ఈజ్ అ కండక్టర్ సార్. అదే కదా, రైట్. చెప్పోరా, let us say here the resistivity is rho. అంటే the total resistance between this two is should be equal to the total resistance for this. So ఇది నా R net value రా, ఇది నా R1 value. ఎక్కడ వచ్చి it is నా R2 value. అదే కదా సార్, because they are connected in series. Hey, there must be a prior knowledge also, Ray. You'll ask me, sir, why are you teaching in the series? I have not talked also. It is class 8th portion. And you can simply say R net is equals to R1 plus R2. అంతే కదా. R net అంటే ఏంటిరా? Rho net, L net, A net is equals to rho 1, L1, A1 plus rho 2, L2, A2. అదే కదా, రైట్. ఇప్పుడు సబ్స్టిట్యూట్ చేసుకోండిరా వాల్యూస్. చెప్పు, rho net multiplied by L net. How much is L net, right? This plus this, 5L divided by A net is A only, ante kada. That should be equals to rho 1 value cheppura. Rho 1 value is rho. L net value cheppura. L net is L divided by A net is A only plus ekkada rho 2 value ra 2 rho. Yes, so rho 2 is 2 rho into L2 value cheppura. L2 value is 4L divided by area is A. Ante sir A gone. Sir, L also gone. What is remaining, ra? 5 times of rho net is equals to rho plus 4 2s are 8 times of rho. Ade kada. That means 5 times of rho net is equals to 9 times rho rate, and rho net is equals to 9 by 5 times of rho. Ade. So this is your net resistivity. Okay, how many people are watching? Next. Good. So, sir, let us shift this and let us talk about the formula now. Ohm's law ante enti ra? Ohm's law ante it simply states that, cheppandi andariki, it simply states that the voltage across the resistor, sir, V is equals to I into R. Ante enti ra? Ante enti? R is equals to V by I kada. R is equals to V by I. That means, sir, if I change voltage, listen to me. If I change voltage, does the resistance increase? No. If I change current, does resistance decrease? No. Ante, even if to your eyes, even if it seems like this resistance is dependent on voltage and current, can it's not. Actually, you make a star mark. Andariki చూసుకోండి, resistance is independent. Okay, the resistance is independent of voltage and current. అదే ante kada. Yes. So to verify the Ohm's law, what we did is we take a voltmeter, okay, and then we are connecting it with a battery. Okay, and what should we start? What did you see? Okay, So let us say here we are applying ammeter also. Here it's a key ra. Key ante telusa, key ante button. Cut. Now when you connect it, you observe the variation of voltage with respect to resistance. So when the graph was seen ra, చూసుకోండి, when the VR graph was seen, అందరికి, so ఇదే నా voltage, ఇదే నా resistance, అంతే కదా. So you increase the value of voltage and resistance, you change, you do the permutation and combination. This was the graph. Ante you can say this graph was coming as a straight line, ante kada, straight line. So that means you can say these are ohmic materials, or ohms material. For voltage versus resistance graph, it was done for some other metals also, but they did not show a straight line, and they either showed like this deviation or this deviation. So these material themselves, these mediums, these metals themselves, they are called as non-ohm material. Yes, you remember it, గుర్తుపెట్టుకోండి అదే, రైట్. సో ఇప్పుడు why number decrease so suddenly ra? Okay sir, okay, let us talk about an important topic now. Okay, చూసుకోండి. What are you talking, sir? ఏం మాట్లాడుతున్నావు సార్? Good, mysterious, very good. Okay, so you take two different resistors, okay. This is my first resistor. Ante resistor ante telusara, resistivity rho 1, and immediately next to it you take one more resistor, and the resistivity will be rho 2. చూసుకోండి అందరికి. And the resistivity here is rho 2. When you see the junction ante enti ra? Junction ante e point, చూసుకోండి, it is the junction, ante kada. This is the junction. ఏమైతది రే? I'm telling you the phenomena, very important phenomena. Listen to me very carefully. When the resistivities are different, resistivities ante materials are different, then it was observed when you connect it with a battery, not like this, something like this. When you connect it with a battery, automatically in this part no charge deposited, okay, no charge deposited. Charge ante extra electrons, no electrons deposited, all the electrons are flowing. Here also all the electrons are flowing, but when you see the junction, there was some electrons accumulated, charge accumulated on the junction. Enduko sir? Why did this charge come, sir? Because of these density differences, ante kada. I hope you are able to understand it. Okay, good. చెప్పండి అందరికి. So we have to calculate the amount of that charge accumulated, ఎలా క్యాలిక్యులేట్ చేయాలి సార్? Gauss law గుర్తుందా? Gauss law from current electricity. Okay, yes. So to calculate that charge accumulation, మనం Gauss law కి యూజ్ చేద్దాం, చూసుకోండి అందరికి. So this is my first conductor ante resistor. Okay, this is the junction. Junction ante I'll represent it with another color. Okay, so this is my junction, this is my another conductor, చూసుకోండి. So this is my another conductor, అదే కదా? Yes, be very careful all of you. Here resistivity is rho 1, here it is rho 2, ante kada, right? Did we discuss Gauss law? What does it say? Gauss law states that change in the flux is equals to the charge inside divided by epsilon naught. Ante kada charge accumulated by epsilon naught. Change in the flux. Change in the flux ante entira delta phi. Leda, you can also say, sir, phi 2 minus phi 1 is equals to charge divided by epsilon naught. Phi ante enti re? Phi ante it is the product of electric field and area. Yes, electric field and area. Ante area is the same. Remember, sir, it is nothing but E2A minus E1A is equals to Q inside divided by epsilon naught. What about E ray? What should I write E? You remember that differential form of Ohm's law? What is the differential form of Ohm's law, sir? Sir, E is equals to E is equals to rho into J. Rho into J. Yes, yes. Sir, E is equals to now you have to remember the formulas. Sir, E is equals to rho into J. J ante enti, sir? Current density. Current density. Ante, sir, E is equals to rho into J is current density. Ante current by area ra. Chuskondi. So this E is my value ra. So you can simply say E to A ante E2. Sir, rho 2 into I divided by A. It is the value of E2 ra into A minus E1 value cheppu. E1 ante rho 1 into I divided by A into A is equals to Q divided by epsilon naught. Ade kada A gone. Cheppora I common teeskondi. So here you can say rho 2 minus rho 1 into I is equals to Q by epsilon naught. And Q is equals to epsilon into rho 2 minus rho 1 into I. This is the charge accumulated. Okay. Very important, okay, very important results. Andariki chuskondi. Now I want to give some other questions that are based on this. Okay, the question is find charge accumulated on the junction. Okay, not surface, on the junction. Teeskondi. So this too much thick, too thick. It should be thin, something like this, right? Yes. So this is my first conductor. The length and area are the same, length L, area A does not matter. Okay, does not matter. Chuskondi. This is my second conductor. Okay, now I'm giving you small values. The whole board is getting covered. Okay? Area is A. Resistivity is rho. Ekkada vachi resistivity is 3 rho ra. Okay, length is L ade kada. Area is A only. Connected to a battery of potential difference V. Cheppandi, I am giving you 5 minutes time. Okay, ఈ 5 minutes లో చెప్పండి ఆన్సర్ ఏం వస్తుంది. చెప్పండి అందరికి. వాట్ ఈస్ ద ఆన్సర్ రా చెప్పు. Okay, so sir, first let us talk about current. Formula ఏంటి రే? ఫార్ములా ఏంటి సార్? Q is equals to epsilon naught into rho 2 minus rho 1 into I. అదే కదా? Yes. So నాకు I వాల్యూ కావాలి రా. So how to find I? Sir, I is equals to V by R. R అంటే resistance. Which resistance sir? నా దగ్గర రెండు resistance ఉన్నాయి కదా. I want to combine them and form a new resistance రా. చెప్పు. Sir, current charge accumulated is equals to epsilon naught into rho 2 minus rho 1 into I. This is a very important formula, all of you remember it. Okay, let us add into the formula list. Let us add this also and that also. Okay, where is the formula list? Yes, there is the formula list. Okay, let us add the formula list. How many formulas? 9. It is my 10th formula. Chuskondi. Okay, this is my 10th formula. Andariki. What do I say? Charge accumulated. Charge accumulated. Accumulated or accumulated? Spelling enti ra? I don't know. Okay? You remember. Charge accumulated at junction of two resistors. Ante Q is equals to epsilon naught into rho 2 minus rho 1 into I. Ante rho 2 is the resistivity of the second material kada? Yes. And I ante current. Finished ra? 10 formulas still now. Okay, 10 formulas still now. Andariki chuskondi. Next, let us directly jump to our main question ra. Cheppandi. So here you can simply say current naku kavali ra. How do I find current sir? Current is equals to I is equals to V divided by total resistance R net kada. Yes, ఇప్పుడు R net గురించి మాట్లాడతాం. చూసుకోండి. R net అంటే ఏంటి సార్? R1 plus R2. ఎందుకంటే సిరీస్ అంటే సార్ R net is equals to R1 plus R2 రా. R1 వాల్యూ ఏంటి రా? R1 వాల్యూ is rho L1 by A1. అంటే rho 1 L1 by A1 plus R2 వాల్యూ is rho 2 L2 by A2. అంతే కదా? ఏరియా is సేమ్. చూసుకోండి. ఏ సేమ్ ఏరియా రా. చెప్పు. rho 1 వాల్యూ is rho L by A plus చెప్పు 3 rho L by A. అదే కదా? So you can simply say R net is equals to చెప్పండి 4 into rho L by A. ఇది నా R net కి వాల్యూ సబ్స్టిట్యూట్ చేసుకోండి. I is equals to V into area divided by 4 rho L. This is my current value ra. Substitute. Sir, charge accumulated is equals to epsilon naught into rho 2 minus rho 1. అంటే 3 rho minus rho multiplied by I value ra. I value is V into A divided by 4 into rho into L. అదే కదా? Yes. Epsilon naught into 3 rho minus rho is 2 rho into VA by 4 rho L. Rho gone. అంటే Q is equals to చెప్పండి V into A divided by 4. Hey, 2 ones are 2, 2 twos are 4 kada. So this 4 is also gone, right? I'll simply take 2. So it is 2 చెప్పు L into epsilon naught. అదే. So this is my charge ra. Charge is equals to చెప్పండి what is the formula re? Charge is equals to VA epsilon naught by 2 into L. చూసుకోండి. So this is the accumulated charge on the surface. అంతే కదా? What is going on in the chat section నాకు తెలియదురా. Okay, I'm really not understanding. ఇప్పుడు let us talk about combination of resistances. Okay, combination of resistances. Combination, series parallel. Yeah. Series parallel. And I have two ways to express this combination. It's not holiday today. Okay? It's not holiday today. Choose. This is a symbol of resistance in physics. Let us say this is R1 value. Choose. Here the value is R2. First combination we are gonna see is series. This is modati combination. Choose. Ante series. Point number 1 to be noted. Andariki. Hey, point number 1 to be noted. Epadaina your resistances are in series. The current remains same. Okay? Current remains. It is the biggest misunderstanding of students. Sir, resistance eats the current. Ledu. Resistance does not eat the current. Resistance eats the potential difference. Okay? Resistance eats the potential. Choose. I am giving you a hint. What is the hint, sir? Resistance changes potential. Ante eats potential. Resistance changes ante it eats potential. Right. It will destroy the potential only. Kani not current. Current remains same. Ante entira? Ante ee resistance nunchi I am passing 2 ampere of current. Enters 2 ampere, exits also 2 ampere. Does not matter whatever the resistance is. Understanding, current remains the same. Okay, good. Now come here, Sheppo. Sir, if voltage of the battery is V, ante total voltage kada, voltage across each of the resistor, it aids some. Both togetherly 8 total V. Ante choose ko here potential is V1. Here potential is V2. What you can say, sir, V is equals to V1 plus V2. V1 plus V2. V ante entira? Ohm's law. IR. Sir, I into R net is equals to, cheppandi, I into R1. I should have taken I1 R1 plus I2 R2. Kani I is same. That's why I'm not writing I1 R1 plus I2 R2. I'm only writing I into R2. Choose. I gone. Ante net resistance is equals to R1 plus R2. Ide kada? Right. Teeskondi. Next. Choose. Andariki. Let us talk about second combination. Ante resistances in parallel. Okay? Parallel. Cheppo. Parallel resistances ante entira? So this is your resistance R1. Ide me resistance R2. Ante kada? Voltage is V. Voltage is V, sir. It is R1, sir. It is R2, sir. So if voltage is V, voltage across each resistance is going to be V. Enduko, sir? Because a wire does not change the potential. A wire, we assume it. Hey, actually the wire also changes the potential. Ante entira? Whatever potential is in the left of this battery, here, all the points, the potential is same. All the points, same potential. Similarly, here also, all the points, same potential. And choose. R2 is between red and blue. R1 is between red and blue. And both the potentials are equal. Ante kada? Right. So what will happen now? Potentials are equal. Right? Potential is V1. V1 ante V. Here also potential is V1. V1 ante V. V2 ante V. V. Same potential. Now there is a twist in the current. Twist in the current. Ante enti, sir? If the current I is flowing, total current I is flowing kada, I goes here, it will break, sir. It will break into I1 and here kindaki I2 veltundi. So you can simply say net current I is equals to I1 plus I2 ante kada. I ante entira? I ante enti? V by R. Ohm's law. Yes, sir, V by R net is equals to V by R1 plus V by R2. Hey, I should also have written V1 by R1 plus V2 by R2. Kani V1 and V2 same untundi kada. That is the reason why I am skipping V and cancelling them out ra. Okay, so ikkada nunchi 1 by net equivalent resistance is equals to 1 by R1 plus 1 by R2. Good petkondi. If you have two resistors only ra, okay, I am extending some things ra, chuskondi. In parallel resistances only, shortcut I am giving you, okay? Case number 1 and ekkada vachi it's case number 2 ra. Case number 1 lo మీ దగ్గర ఒక only two resistors are there, okay? So రెండు resistors ఉంటే you can simply remember this formulas, okay? What formula, sir? ఇదే నా resistors R1, it is my resistance R2. చెప్పండి R1 R2 replace చేసుకోండి with a new resistor ra. Replace it with a new resistor. Replace it with a new resistor ante this is my net resistor R net. Cheppandi, it is R1 value, it is R2 value. So you can simply say, sir, R net is equals to R1 R2 divided by R1 plus R2. You remember it. If you have only two resistors, you don't go 1 by R1 is equals to 1 by R2 1 plus. Hey, that's too complicated, right? You remember this when you have only two resistors, okay? Multiplication divided by addition. R1 R2 by R1 plus R2. Later, if you have multiple resistors of same value, multiple resistors of same value, I should shift it there, little here. Just second case, multiple resistors having same value, ante kada, having same value. For example, in parallel, I'm telling you, these are the only cases of parallel. Series and it's very easy, Ray. It's very easy. You simply have to add them. And in parallel, koncham twist untundi kada. Right. So if you have the multiple resistors having same value, ante here is R, here is also R, here is also R, here is also R. There are four kada. Chuskondi R, 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 R. And net resistance is R by 4. Why 4, sir? ఎందుకంటే 4 resistances are there రా. 3 ఉంటే R by 3, 2 ఉంటే R by 2, అదే కదా. So it is R, it is R, it is R. Net resistance అంటే R by 3. Shortcut, okay? All of you remember it. Remember this short. Okay? Good. లేదా you can say, sir, this is resistance, this is resistance, this is resistance, sir, it is also resistance, sir, it is also resistance, and infinite and n resistors in parallel ra. Ivannitki value R. Chappu, what you can say, sir, net resistance is equals to R by n. Ade, this is the simple short trick that you have to remember, okay? Ardhamaindi andariki? Nice. చూసుకోండి. సో ఇప్పుడు let us talk about some questions రా. Later, you find current only, okay? Find equivalent resistance. No, find the current. For the following. First case, ra, తీసుకోండి అందరికి. So this is my battery, okay? 10 volt battery is there, అందరికి చెప్పండి. So it is my first resistor and then it is my second resistor. Simple questions which start చేస్తున్నాను. Let us slowly move towards the complex questions, okay? So this resistor is 3 ohm. ఎక్కడ వచ్చి it is also 3 ohm. It is also 6 ohms. చెప్పండి అందరికి current directly చెప్పండి values. నాకు values కావాలిరా, okay? I don't want time pass. Hey. So, sir, let us first talk about net resistance. So, net resistance ante ee rendu are in parallel and they are in the series ante kada. Parallel, you remember two resistances. Two resistances unte what is the formula? For two resistances R1 R2 by R1 plus R2 ante kada. So you can simply say, sir, for these two net resistance is equals to R1 R2 divided by R1 plus R2 ante kada. Value substitute ra, or if possible you remember these 3 and 6 values or multiple values also. Okay, 3 6 they are the standard values. Okay, they get simplified ante enti ra ante this is 3 into 6 divided by 3 plus 6 అదే కదా 3 into 6 18 by 9 అంటే 2 ohm. Perfect answer వచ్చింది. So net resistance is 2 ohm ra for these two. So it means ఇదే నా 3 ohm resistance and ఇక్కడ నుంచి ఇట్స్ 2 ohm కదా, రైట్. 3 2 now they are in parallel series అంటే యాడ్ చేసుకో, డైరెక్ట్ యాడ్. 3 plus 2 5 10 volt is the battery resistance, current is equals to 10 by 5 అంటే 2 ampere అదే కదా. But before that next question తీసుకోండి. Find current ra. Sir, what are you doing, sir? Huh? Not be like this, sir. Accurate figures తీసుకోండి. Symmetry should be followed ra. Everywhere the symmetry should be followed. Okay, like this. If you are doing this question under my fear of you not understanding the question will be gone. అదే కదా. So this is my battery ra. తీసుకోండి. I have to give the values very carefully, okay? So let us say it is 3 ohm, it is also 6 ohms. It is 1 ohm, it is 6 ohms. Okay? 1 ohm, it is also 6 ohms. Okay? Not like this, not like this. Okay? Not like this. So it's not 1 ohm, you take it as 0.5 ohm. 0.3 ohm ఎక్కడ వచ్చి 0.7 ohm చెప్పండి అందరికి. ఓకే, సిక్స్టీన్ వోల్ట్ బ్యాటరీ ఇస్ దేర్, తీసుకోండి అందరికి. You will have to cover everything very quick, huh? Because we don't have much time. Yeah. Hi Dikshita, hi. Okay. Hey, చూద్దాం రా. చెప్పు. 3, 6, I told you. 3, 6, they are standard resistors, ray. So it becomes 2. And in place of this 3 and 6, what you do is there the option to copy the page, ray? Is there the option to copy the page? No. Let it be. Okay? I think I'll have to wipe it. Choose Kora. Instead of this 3 and 6, you can directly write 2. 3 ohm resistor, 6 ohm resistor, parallel load. I'm good. Dikshita, I'm fine. You're talking to me only, right? You're talking to me. You're talking to someone else, right? Hey, 3 and 6 are in parallel. So they are in parallel until the resultant will be 2 ohm. So, array, తీసుకోండి రా. Hey, ఇది తీసి, you simply write 2 ohm resistor. Hey, 2 ohm రా, 2 ohm. అంటే 2 and 3. మళ్ళీ series అంటే 2 and 3 becomes 1 ohm రా. You directly wipe it out and write 2 and 3 becomes 2 and 1 becomes 3 ohm. చూసుకోండి 3, 6. మళ్ళీ in parallel. And there will be 2 ohms. You remove everything, it will convert into 2 ohm ra. Chuskondi. So it is 2 ohm. 2, 0.3, 0.7 becomes 3. Hey, 3 plus 6. Again parallel. They become 2 ra. Hey, you remove it, it becomes equal to 2 ra. Hey, all of it is gone. It is gone. And it is simply equal to 2 ohm. 2 and 4, they are in parallel. And you can directly write రెండు resistors ఉన్నాయి కదా, R net is equals to R1 R2 divided by R1 plus R2. చెప్పు 2 into 4 that is 8 divided by 2 plus 4 అంటే 8 by 6. 8 by 6 అంటే 4 by 3 కదా. Yes, this is my net resistance రా. Okay, so instead of these two, you remove these two and write a single resistance of 4 by 3 ohm. అదే. So ఈ మొత్తంని remove చేసి you write a single resistor R is equals to 4 by 3 ohm. ఎక్కడ నుంచి కరెంట్ కావాలి కదా, V is equals to I into R and I is equals to V by R. V value ఏంటి? 16 divided by R value ఎంతరా? 4 by 3 అదే కదా. So that is 16 into 3 by 4, that is equals to 12 ampere of current. తీసుకో. Next, let me just tell you, okay, let me just revise you quickly. Okay, all of you, again it's a humble reminder from my side, okay, for all those students who have not registered for YSET test. The link will be in the description section. You go and click the link, register yourself. Registration is absolutely free of cost. Hey, this test will be very helpful in deciding your current position nationally amongst the students who are aspiring, your competitors. Okay, Malli, I'm telling you, the exam dates are starting from 4th of January. Meeku 3 tests unnaira. Chuskondi. You have 3 tests, 4th of Jan, 11th Jan and 18th of Jan. NEET students kosam, the timings are same, 2 PM to 5 PM. Last date to register is 3rd of January. So it is 1st, 2nd, 3rd, 2 days unnai kada. So you register, go and register by yourself into it. Okay, all of you. Right. Chuskondi. So now let us jump on variation of resistance with temperature. Okay, variation of resistor or resistance చూసుకోండి. అంటే ఏంటి సార్? సో ఇఫ్ ఐ హ్యావ్ ఎ రాడ్, let us say నా దగ్గర ఒక రాడ్ ఉంటే, ఈ రాడ్ it will have some resistance కదా. Yes, what is the formula for resistance? Sir, R is equals to rho into L by A. అదే కదా. You can take this also, you can skip this also. Okay, for now let us skip it. This is the rod. So and when I'm connecting this rod with a battery, it is going to resist the flow of charge. ante kada. So it is my battery. Ide na battery. Chuskondi andariki. So voltage is V, resistance is R. Chusko. Now what I'm doing is I'm heating this whole setup. Heating ante the length will be increased. the temperature increased, temperature of the rod increase అయితే the electrons motion will be increased and the number of collisions also increased. చూసుకోండి రే, I'm talking only about the basics, right? There are number of electrons, they are colliding with one another, అంతే కదా? Yes, so if you are increasing the temperature, kinetic energy of electrons increases and collisions also increases and resistance will change, అంతే కదా? సో మా దగ్గర 3 scenarios ఉన్నాయి రా, చూసుకోండి. Number one, resistance as you increase the temperature, we have 3 cases రా, చూసుకోండి. Number 1, మీ conductor, your material is a conductor. Number 1, conductor. Okay, number 2 is your semiconductor రా, చూసుకోండి. And మూడోది it is your insulators. We don't talk about much for the resistance of insulator ఎందుకంటే they are perfectly highly resistive objects కదా. Yes, చూసుకోండి. For conductors, if you increase the temperature, resistance also increases. If you decrease the temperature, resistance also decreases. Very simple rule. కానీ for semiconductors, if you increase the temperature, resistance decreases and vice versa. For insulators, if you increase the temperature, resistance will decrease but very slightly ra, okay? Resistance decreases slightly ante enti ra? Slightly ante does not matter, it almost remains the same, okay? Slightly decrease ante almost remains the same. Andariki chudandi, it could be directly asked to you, hey, this could be directly asked as a MCQ question. Next చూసుకోండి అందరికి. Now let us talk about the mathematics. We hate mathematics, sir. If we love mathematics, why would we choose NEET, sir? చూసుకోరా. సో ఇదే నా కండక్టర్, ఓకే? రాడ్, you can assume it to be the rod, okay? చూసుకోండి అందరికి. What's happening now is, you imagine the temperature is T. I'm heating this, again heat చేస్తున్నారు, చూసుకోండి. హీట్ చేసిన తర్వాత the temperature has increased to T plus dt, అదే కదా? చెప్పోరా, it is my initial temperature, ఇదే నా initial temperature and this is my final temperature. అందరికి చూడండి, what is the change in temperature రా? Delta T is equals to T final minus T initial అంటే dt, అదే కదా? Right. ఇప్పుడు you understand the initial resistance for temperature T was R, the final resistance has become R plus dr. Small change kada, small change. Ante change in resistance entara? Change in resistance is dr. Ade kada? Yes. So the scientists have found that the ratio, sir, the ratio of dr by dt, it was directly proportional to the initial value of the resistance ante R. చూసుకోండి, it is initially directly proportional to the initial resistance R. అందరికి అర్థమైంది కదా? రైట్. సో సార్, రిమూవ్ దిస్ ప్రపోర్షనాలిటీ సైన్ అండ్ ఇంట్రడ్యూస్ అ కాన్స్టెంట్. yes. సో సార్, dr by dt is equals to alpha into r. alpha అంటే థర్మల్ resistivity constant. Okay, so you can simply say, sir, let us do some mathematics now. dr by r is equals to alpha into dt, అదే కదా? yes. ఇప్పుడు ఇంటిగ్రేట్ చేసుకోండి రా. సార్, టూ మచ్ హెడేక్, ఐ నో, నాకు తెలిసి, ఐ నో టూ మచ్ హెడేక్, కానీ వాట్ కెన్ యూ డూ? ఇట్ ఈస్ దేర్ ఫర్ యువర్ సిలబస్, వీ కాంట్ డూ ఎనీథింగ్, రైట్? గుడ్, ఓకే, గ్రేట్. నౌ ఇంటిగ్రేట్ చేసి, ఆఫ్టర్ యూ ఇంటిగ్రేటెడ్, చెప్పండి వాట్ ఈస్ ద రిజల్ట్ యు ఆర్ గెటింగ్? dr by r dx by x, ఇంటెగ్రల్ dx by x log x. log x అంటే సార్, log x అంటే ln of r, అంతే కదా? ఇనీషియల్ వాల్యూ r, ఫైనల్ వాల్యూ, ఇనీషియల్ వాల్యూ r naught తీస్తే, we are taking r naught, final value as r, is equals to alpha into integral alpha into dt, అదే కదా? dt అంటే టెంపరేచర్, alpha dt అంటే టెంపరేచర్. ఇప్పుడు మీ దగ్గర రెండు కేసెస్ ఉన్నాయి రా. ఫస్ట్ ఇస్ వేర్ alpha is constant. alpha కాన్స్టెంట్ ఉంటే you simply take it out of the integration sign, అంతే కదా? ఓకే సార్, what I have is ln of upper limit r minus ln of lower limit r naught is equals to integral alpha into dt. Ade kada log a minus log b ra, log a by b. Yes, so ln of r divided by r naught is equals to integral alpha into dt. Ade kada, so you send that side. So if you are sending that side, that means it will become r by r naught. This is remaining. This ln becomes e ra. So e to the power integral alpha dt. So ikkada nunchi r is equals to r naught e to the power integral alpha dt. Are there? Right? Yes. So let us expand it and let us write once again. Chuskondi. R is equals to r naught into cheppandi e to the power e to the power integral alpha dt. If alpha is constant, take it out. So sir, r is equals to r naught into alpha integral dt. Integral dt ante delta t ra. Small changes become big change. Ante r is equals to r naught into e to the power alpha delta t. Sir, too complicated, sir. Too complicated, sir. Simplify cheddam. Chudandi. E to the power x. It could approximately be mathematics. Some mathematics people came and they told us, sir, e to the power x can be written as 1 plus x. You can write. So I am writing, okay? Binomial expansion. It is known as binomial expansion. Choose kondira. So you can simply say r is equals to r naught into e to the power x kada 1 plus x. And e to the power alpha delta d 1 plus alpha delta d. So this is the temperature relation of resistance. Choose it's a very important thing. Okay, alpha is the coefficient of thermal resistivity. Thermal resistance. Okay, what is alpha? Alpha is coefficient of thermal resistance. You should technically have a question, but if you don't have it, I'm happy. Okay, I'm happy. The question is, sir, if you are increasing the temperature, length also increases. And the expansion of solids, while you heat it, L is equals to L naught into 1 plus alpha delta T, same relation. So, sir, if the length is increasing, the resistance should also increase. Understanding, resistance should also increase by expansion. It's not due to expansion, it is just due to the electron collisions. Understanding, leave it, nothing. Okay, this is the relationship. Okay, this is the relationship of temperature variation with a resistance variation with respect to temperature. You're saying something, all of you. There is a small topic, chinna topic untundi, color coding of resistance, okay? But there are some theoretical topics for that. All of you, okay? Yeah, Kirtana, 11:30 is the time. The session might go till 1 or 1:30 or 2. I don't know. Okay? I don't know. I think we should take a break. Sorry. Okay? We'll be back after 11:45. Let me also have some breakfast. Okay, so back after the break and let us continue, right? Right, perfect. So what was the last topic, right? Where did we leave it, right? Where did we leave it? Where did we leave it? Okay, so the variation of resistance with respect to temperature, ante kada? Right. Variation of resistance with respect to temperature, andariki. How many of you are there? Okay, perfect. So I think now we'll have to discuss so let us now jump on the graph theory ra chuskondi. Hey, graph theory, not graph theory re, it should be circuit theory, okay? Circuits లేదా electrical circuits గురించి మాట్లాడతాం అందరికి. Okay, okay. చూడండి అందరికి. So circuits అంటే we do have some resistances, we do have battery also, and then we do some permutation combination. దాని తర్వాత we solve the questions, అంతే కదా? Right. చూసుకోండి అందరికి. So this is a standard battery ra. Okay, I'm starting from a very simple circuit and then we'll jump to KCL, KVL, wheatstone bridge, wheatstone bridge, and after that we'll discuss about the internal resistance of a battery, combinations of batteries, series and parallel. Then I think that will be sufficient. Chudam. V R value 2 ohm, V value 10 volt. Cheppandi sir. Very simple process, done, completed, right? But what if branches are there? Branches ante enti? Let us take with a very basic example. Andarki chuskondi, all of you students. So when you are moving in a branch of a circuit, how will you respond to the potential values? Okay, so first branches lo let us talk about potential change ra. Hey, potential change. Potential change ante enti sir? I will take it, don't worry. Chuskondi. There is nothing known as potential kada? Yes, there is nothing known as absolute potential. Eppudaina we talk about potential, we only talk about the relative values, ante kada? Yes, the potential difference. Specifically we talk about the potential difference. Chuskora. So if this is my resistor, okay, this is my potential point A, ide na potential at point B, ante kada? There is no potential at a given point. You understand, when I'm saying potential at A, I'm considering the potential at some point to be 0. Then and only then I'm comparing this potential. Choose for I. I'm telling you, sir, if no current is flowing, it's a very important statement. It's a very important statement. Choose kondi andariki. Potential at A minus potential at B, ante change in the potential will be 0. Understanding VA minus VB ante delta V. Delta V is 0 always. That means VA is equals to VB. Chuskondi ra. Okay, statement number 1 complete ayindi andariki. So let me just shift it to this side. Here. Here. Let us shift it here. Okay. What if the current is flowing ra? Okay, if the current is flowing, chuskondi andariki. If the current I is flowing, what will happen then ra? If the current I is flowing, chuskondi andariki. If this is my resistor and the current is flowing like this, chuskondi current I, direction also matters a lot. Current always flows from higher potential to lower potential. That is a statement, you remember it, okay? Statement chuskondi ra. Statement is this: current flows from high potential to low potential. Ante enti sir, ee situation lo the current is flowing from point A to point B, ade kada? Yes. So that means potential at A is higher than the potential at B. Ante kada? Yes. Chuskondi ra. If there is current flowing, that means resistance value will decide how much is the potential difference. Chuskondi. It's a very basic understanding when you are solving the problem on resistances. Chusko. What is the understanding, sir? The potential difference between the ends of the resistor. The potential difference between the ends of the resistor. VA minus VB. Ade kada? Yes. That should be equals to the current into the value of resistor. Chuskondi. If current is 0, I becomes 0. I 0 ayina tarvata VA minus VB becomes 0. Chuskondi. Same case. VA is equals to VB. So always remember, if you have a resistor and the current is flowing, until there is a potential difference across the resistor. Ardhamaindariki. What will happen? Chuskondi. What will happen if you have zero resistor? Ante proper wire ante kada. If you have a proper wire, cheppu. If this is point A, VA, if this is point B, VB, let us say it is 10 volt. I am giving you example, okay? Okay, example తీసుకోండి. VA at 10, VB at 5 volt. చెప్పండి అందరికి. Resistance 0 కదా? Yes, resistance is equals to 0. చెప్పు. What will happen? Sir, resistance is 0 అంటే it's a proper wire. In that case, VA minus VB should be I into R. అంటే sir, 10 minus 5 is equals to I into 0. Resistance 0 kada? What is the value of I rate? I is equals to 10 minus 5 divided by 0. Infinite current. Understanding? Infinite. Not possible. Literally not possible. So that is the reason why we say in a wire, potential at each and every single point is same. Understanding? So that means it is not possible to have different values. So what will happen, sir? Na daggara oka battery untundi, sir. This is the battery, okay? This is the positive terminal, this is the negative terminal of a battery, sir. I am taking a wire, proper wire, sir. I am taking one more wire, sir. Now I want to join them. What will happen? So here potential is 0, here the potential is 100 volt, okay? 100 volt battery is there. So it maintains a potential difference of 100 volt. So 0 volt oka wire తీసుకోండి, 100 volt oka wire తీసుకోండి, join them. What will happen? Spark telusa? Let it be. If you don't know, let it be. Hey, why I am telling you all these things, right? Because it is not possible to change the potential in a wire. Meeku oka resistance kavali. If at all you have to change the potential. Understanding, if at all you have a potential difference, there must be a resistor. If there is no potential difference, until the potential or the resistor should become 0. Okay. The only thing is that if the potential difference is same, until either the battery is not connected. You remember this, okay? Hey, you remember that this is resistance. This is also resistance, ra. Okay, R. It is my point A. Ikkada kuda na point A ra. This is my point B. This is my point B ra. Chuskondi. If at all, you say potential at A is equals to potential at B. Understand, it can only mean two things. Point number 1 is either resistance is equals to 0 until it is a wire, not a resistor, okay? Even in wire, the resistance is not 0 actually. There is some resistance. Leda, resistance is there, R value is there, but no current is flowing. Remove it. Resistance is there, but no current is flowing. And it's just a simple resistor. It can only mean two things. It can only mean two things. And if you are talking in a circuit, 2 points are equal. Either resistance is 0 and it's a wire, leda the circuit is not connected to any battery. Ante kada? Good. Chuskondi. Eppudu we will jump on the calculating part of the resistances. Chusko. Hey, question is find potential at A minus potential at B. Cheppandi. So this is my point A ra. Okay? Resistor, battery, resistor, battery, resistor, battery, resistor. It is my point B. Chuskondi. The current is flowing in this direction. I'll take this different color. So ఇదే నా కరెంట్ ఐరా అందరికి చూసుకోండి. సో రూల్ గుర్తుపెట్టుకోండి, రూల్స్. I told you about resistance కదా. ఇప్పుడు I'll talk about the battery. చూసుకోండి రా, బ్యాటరీ గురించి చెప్తున్నారు అందరికి. సో now let us talk about the battery. బ్యాటరీ అంటే ఏంటిరా? This is the battery. చూసుకో. If you are going from lower terminal అంటే small rod to big rod, small rod to big rod అంటే negative terminal to positive terminal. If your direction of motion is like this, you add plus ante add the voltage of the battery. Understanding? Add the voltage of battery లేదా potential increases or potential increases. Chuskondi re, it's a very elementary things. Okay, potential increases. In other scenario cheppandi andariki, if you are doing the reverse ante enti sir, it is my big terminal, it is my small terminal. Ante you are going like this from bigger to smaller, pedda nunchi chinna varaku ra. Chuskondi. So in that scenario, you what do? Potential decreases ra. Potential decreases ante you subtract the voltage. Okay, potential decreases ante enti ra? Okay, subtract the voltage of the battery. Ante kada? Yes, subtract the voltage of battery. Ade chuskondi ra. This is the only case. In resistors it is always decreasing. Resistor always eats the potential ra. Okay, resistor always decreases the potential. Take the star mark andariki. Star mark. Resistor always decreases the potential. With that being said, jump to our main question. Cheppandi andariki. Resistance value R1, value R2, value R3, V1, V2, V3, R4. Cheppandi andariki. I current is there. Current is I. Let us slowly, okay? Jump on the next topic. Okay, next topic and next point ra. Your interested points are these much. Chuskondi. First resistor completed, jump to this point. Dan tarvata jump to this point, and then jump to this point, and then jump to this point, and then jump to this point. Dan tarvata ekkada ochindi and here come to this point. Ade kada. These are the flow of events. You have to jump to the next topics, next points. Andariki chuskondi. Okay, good. Cheppandi. Resistor always decreases the potential. How much decrease? I into R. A resistor always decreases the potential by I into R. Chuskondi. Not R5. Why? R1, R2, R3, R4 kada. Finished. Chapora. So point, let us say this point is B ray. This point, not B ray. B already taken kada. Yes. So let us say this point is D. Ide na point E. Ide na point F. This is my point G. This is my point H. This is my point I. And dan tarvata B. Chuskondi ra. Sir, VA minus VD ra. The ink is creating problem. Okay, cheppandi. Sir, VA minus VD is equals to I into R. Potential difference across the ends of a resistor. Same. Cheppandi. So ekkada nunchi what you get, right? You can simply say, sir, VD is equals to VA minus I into R. It is mathematical, okay? Mathematically, you are writing these things back and forth. But if you want to go directly, you can directly jump. Resistor always needs the potential kada. Cheppandi. At this point, potential was VA. It has been decreased by IR1. So it is VA minus I into R1. Direct la. Cheppora. At this point, potential cheppu. Negative to positive. Potential increases. Add it. Sir, total potential was VA minus I into R1. And due to battery, it is getting increased to V1. come at this point రా చెప్పు ఈ పాయింట్ లో చెప్పండి అందరికి resistance is there, it will eat the potential, అంటే it will decrease it. So total potential was VA minus IR1 plus V1, it was the total potential. Resistance is consuming minus IR2. R2 is the resistance. చూసుకోండి. Done. Go to this point. చెప్పండి అందరికి ఈ పాయింట్ లో you are traveling from positive to low negative terminal అంటే decrease. Subtract the potential. Total potential was this. దీంట్లో వచ్చి సబ్ట్రాక్ట్ V2 రా అంటే VA minus IR1 plus V1 minus IR2. This was the original potential. చూసుకోండి. దీంట్లో వచ్చి you have to subtract the battery potential. ఎందుకంటే రివర్స్ టర్మినాలజీ కదా, పాజిటివ్ టు నెగటివ్ minus V2 అదే. So this is the potential at point G రా. Now I want potential at point H. చెప్పండి అందరికి resistance is there, it will always decrease the potential. And the total potential was VA minus IR1 plus V1 minus IR2 minus V2. It was the original potential kada. You decrease it. How much it will decrease, sir? Current I into resistance R3 minus I into R3. Ade. So you talk about this potential ra cheppandi andariki. So here a battery is there, negative to positive terminal, add the potential cheppandi andariki. So it is coming out to be VA minus IR1 plus V1 minus IR2 minus V2 minus IR3. It was the original potential. Deedlo you add one more potential V3 ade. And lastly at this point resistance is there kada, so it will eat the potential and it will decrease it. How much it will decrease, sir? Total current I multiplied by R4 value. The current does not change. Okay, the current does not change. Cheppandi. So what you will say? You will simply say, sir, total potential was this. You subtract I into R4 from this. So sir, VA minus IR1 cheppandi plus V1 minus IR2 minus V2 minus IR3 plus V3 minus IR4. So this complete is the potential at point B. Ade kada? Right. So ekkada nunchi you write this equation ra andariki cheppandi. What do I want? VA minus VB kada. You write the equation cheppandi. So potential at point B is equals to VA minus IR1 plus V2 minus IR2 minus plus V1 kada? Yes, V1 minus V2 minus IR3 plus V3 minus IR4 ade. So let us do one thing, sir. Naku VB minus VA kavala or VA minus VB kavala. So I want this. So send everything this side, everything that side. Cheppandi. So you can simply say, sir, VA minus VB is equals to, I am sending this side and complete to the left side. Cheppu. So it becomes IR1 cheppandi minus V1 plus IR2 minus plus V2 plus IR3 minus V3 plus IR4. Ade kada? Yes. So you can simply say it is equals to V2 minus V1 minus V3 plus I times of cheppandi R1 plus R2 plus R3. Ade kada? Yes. Shortcut chudandi. I'll tell you a shortcut also ra. Andariki chusko. Direct shortcut chuddam andariki. Value V1, V2, V3, V4, V5, V6. Okay? Resistance R1, R2, R3, R4, R5, R6. Okay? So these are the resistances, these are the batteries. Do one thing, shortcut I'm telling you, okay? Shortcut. You remember the ideal direction of a battery. Ante enti sir? Negative terminal to positive terminal ki velte. If you are going like this, then you can simply say the values of potential will increase. Ade kada? Right. So increasing, decreasing, increasing, increasing, decreasing, decreasing, decreasing ante minus, minus, minus. So it is increasing ante plus, decreasing minus, increasing plus, increasing plus, decreasing minus, decreasing minus. Ante V1 plus V3 positive. Mottam everything it's negative. So minus V2, minus V4, minus V5 kada, minus V6 ade. So this is my voltage ra. And resistance always decreases the potential. Until take a negative sign and take the common current ra. I is there. Ante kada. Now all the resistance, they are in series. So directly add everything. R1 plus R2 plus R3 plus R4 plus R5 plus R6. So this is the value of VA minus VB. So it is my point A and here it is my point B. Chooskondira. Okay. Next. So let us talk about KCL. Okay, KCL, Kirchhoff's laws ra. Chooskondi andariki. Number 1, sir. KCL ante Kirchhoff current law. What does it say? What does this law say? Chooskoni andariki. This law simply states, మీ దగ్గర ఒక junction అంటే joint ఉంటే, if you have a junction where you have multiple currents coming, okay? So this is the junction. చూసుకోండి. Now you only know the direction of few currents. అంటే you only know the direction of the current from this part, let us say I1. You only know the direction of this current from this part, let us say I2. Migita, you don't know any direction. Okay? So Kirchhoff law gives you a set of rules. Rule number 1. Okay? Rule number 1, you consider the direction of current of all the branches to be at a single point. Ante enti sir? You don't know these directions kada, you assume they are in the same direction. Same direction ante coming at the same point. Something like this. Ante kada. Let the currents be I3, I4, I5 and I6. Ade chooskondira. What does it say? It simply says add all the currents ra, direct add chesko. I1 plus I2 plus I3 plus I4 plus I5 plus I6 should be equals to 0. Ade ante kada. Endukante if they are coming at a point, they are positive. If they are leaving from a point, they are negative. Negative ante enti sir? Negative ante I will tell you. Chooskora. If you know the directions, ade. So this is the junction ra. Chooskondi andariki. So ikkada it is I1 current. E branch lo I2. Let us say I3 is moving out. And here also I4 is moving out. And here also I5 is moving out. You write the incoming currents ra. Incoming currents are I1 plus I2 only. So I1 plus I2. Incoming positive ra. Outgoing currents will be negative. And minus I3 minus I4 minus I5 is equals to 0. Ade kada? Yes. Cheppandi. Done? Not done ra? Huh? So let us take some questions based on it. Let us take some questions based on your Kirchhoff current law. Okay? Okay. I don't know the values, right? Okay, let us take random values. 2 ohm, it is 4 ohm, it is also 2 ohm. Let the battery be 6 volt and ekkada vachi the battery is 10 volt. Andariki cheppandi. I want to find the current through each and every resistor ra. Naku currents through resistors kavali. How do I do it, sir? Chusko andariki chuskondi. So if you are assuming that it is my junction point ra, chuskondi. If you are assuming it is my junction point, ante kada. But you don't know the direction of currents. You don't know the direction of currents ray, if it is coming up or going left or going right, లేదా coming from right, going down. You don't know anything. So what to do? What to do? You assume it to be a concentric. Concentric ante entira? You either take the directions of all currents towards it, లేదా away from it. Are you understanding? So if you are assuming the direction of currents to be away from it, something like this, you can do it. You can do it. You can do it. Okay, you can do it. Now, let us say this current is I1, ekkada I2, and here the current is I3. Ante kada. Kirchhoff current law simply tells you, cheppandi, I1 plus I2 plus I3 is equals to 0. Hey, చూసుకోండి రా. I1 plus I2 plus I3 is equals to 0. Sir, what is I1, I2, I3? I don't know. Can I know the values of some batteries, ra? So let us start with this assumption. Let us say this point is at zero potential, ra. It is the standard procedure to do the questions. Whenever you don't know anything about the circuit, assume a potential at a general point to be zero, ra. So if here is the potential 0, it's a wire. Wire ante zero resistance. Zero resistance ante potential will be the same. Ante kada. So here also the potential will become 0, ra. Now you come in this side. You are going from negative to positive. Potential increases. Increase the potential by 6 ante at this point immediately it becomes 6 volt, here also 6 volt, here also 6 volt, ante kada. Now go up, again negative to positive, potential increases. This is 16 volt, ra, ade, and at this point you assume the potential to be x, ra, ante kada, ante kada. Right. Now understand, you consider only this 2 ohm resistor, ra. Hey, you consider only 2 ohm resistor. Cheppu, potential difference, how much is across it? Potential difference, I am telling current is flowing like this. So potential difference, cheppu, x minus 16. Sir, potential difference is x minus 16. It is my potential difference. V is equals to IR. V is equals to IR, ra. Okay, V is equals to IR. Sir, V is equals to I into R. Ante I is equals to V by R kada. Yes. So ide na V value, R value is 2, ra. So na I1 ochindi, chuskondi. This is my I1 from 2 ohm resistance. Similarly, tell me here also, Ray, sir, x minus 0 is the potential difference kada. Sir, delta V is equals to x minus 0. What is the value of I, Ray? I is equals to delta V by R. Ante x minus 0 by 2. Right? That is my value of I3. So it is my value of I3. It is I1. I2 గురించి చెప్పండి రా. I2 is going like this kada. చెప్పు, x minus 6 by 4 అంతే కదా. X minus 6 by 4 is my I2 value అందరికి. You add all 3, that should be equal to 0. Andariki, cheppandi. You add all 3. I1 value, ra. I1 value is x minus 16 by 2 plus I2 value, ra. X minus 6 by 4 plus I3 value, cheppandi andariki. I3 value is x minus 0 divided by 2 should be equals to 0. Ade kada? Right. You simplify. How to simplify, sir? 2 multiply up down. 2 multiply up down. Ante kada? So 4. Common denominator, take it common. 2 into x becomes 2x. Minus 16 into 2 becomes 32. Plus x minus 6 plus 2 into x, 2x kada? Yes. 2x. Okay? Yes. Cheppandi. So it is 2x, x, 3x plus 2x becomes 5x, ra. Okay, so you can simply say, sir, it is 5x minus 32 minus 6 becomes minus 38. So minus 38 divided by 4 is equals to 0. Ante 5x is equals to 38. Ante x is equals to 38 by 5. This is a potential. Potential value. Assumption we did for potential kada. So potential ochindi ra. So ee point lo potential is 38 by 5. Ekkada nunchi you can calculate I1, I2, I3. Ade kada. So let us try to calculate that also. Choose I1 value untara. I1 is equals to how much? X minus 16 by 2 ade kada? Yes. So x minus 16 by 2 ante x value is 38 by 5. Hey. X value is 38 by 5 minus 16 divided by 2. Cheppandi. 38 into 80. 38 minus 80 ra. Ante kada? Okay, so sir, it is equals to 38 minus 80 divided by 10. So approximately is equals to minus 42 divided by 10. ante minus 4.2 ampere ra. So this is my I1 current. Negative sign ante enti ra? Negative sign ante whatever we have assumed, it is opposite. So I1 is going like this. I1 is going like this. Okay? I2 గురించి చెప్పండి అందరికి. I2 వాల్యూ చెప్పండి. I2 వాల్యూ రా. I2 వాల్యూ చెప్పు అందరికి. Formula x minus 6 by 4 రా. So I2 is x minus 6 divided by 4. అంటే 38 by 5 minus 6 divided by 4 కదా. Do the cross multiplication. 38 minus 30 sir 8 by 4. అంటే it is equals to 2 ampere of current. I2 వాల్యూ వచ్చింది కదా. Not 4 rate, 20. I should do. Right, by 4. అంటే 38 minus 38. 8 divided by 20. 8 by 20 రా. అంటే 2 by 5 ampere. సో ఇదే నా I2 కి వాల్యూ వచ్చింది రా. ఇప్పుడు I3 గురించి చెప్పండి అందరికి. I3 ఎక్కడ ఉన్నారు? I3 is here. X minus 16 by 12 కదా. Yes. X minus 16 by 12. I3 is I1 I3 re. I1 I3 value. Where is I3? Hey, I3 value is x minus 0 by 2 only re. Hey, I3 value is x minus 0 by 2 only. Ante enti ra? Ante x by 2. X value, how much is x value? 38 by 5. 38 by 5 minus 0 by 2 ante 38 by 10. Idena I3 ki value. Okay? Okay. Ante entira? Ante you can simply do one thing. Okay? 2 by 5 plus 38 by 10 kada. So let us do one thing. You understand the directions also, okay? You understand the directions also. I am drawing the figure by myself, okay? Chuskondi ra. Same figure, I am trying to copy it. I am trying to copy the same figure, okay? I am trying to copy the same figure, andariki. So this was the resistance. This was the, all general values were there, ra. Okay? So this was a battery. Okay? This was also a battery. Chudandi. What did I say, re? We assumed I1, I2, I3. I1, I2, I3, ante kada? Yes. So this value was I1, this value was I2, this value was I3. Kani I1, I2, I3 ki values chudandi ra. I1 value minus 42 by 10 ampere. Cheppandi. I1 value is minus 42 by 10 ampere. I2 cheppandi ra. I2 value enta ochindi? I2 value, sir, 2 by 5. 2 by 5. Oh, right. I2 is 2 by 5 ampere. I3 cheppandi. I3 value enta ochindi ra? I3 value re. I3 value is 38 by 10 andariki. 38 by 10. I3 is 38 by 10. Ade kada? Yes. Yes. Now listen. Listen to me very carefully. Let us talk about directions, ra. Let us talk about directions. Okay? Let us talk about directions. I1 negative kada. So you remove the direction of I1 and take a negative direction. Negative direction ante reverse. So idena I1 ki direction. Cheppandi andariki. So I1 came from right side. It split into two. Came. It is coming half going in down, half going forward. Ante kada, it is coming in this direction. Cheppu. Ante current conservation should be there ra. Telusa? Current conservation ante enti ra? Current conservation should be there. Ante whatever I1 is there, these two are breaking into, I1 is breaking into these two kada. So you should have I2 plus I3 should be equals to I1. I2 value cheppura. I2 value is 2 by 5 plus I3 value cheppura. I3 value is 38 by 10. Cheppandi values. 2 into 10, 20 plus 38 into 5. How much is 38 into 5? 150? 150 plus 40, 190 divided by 50. Ade kada? Yes. So sir, that is equals to 210 by 50. Ante 21 by 5. It is the value of I1. I1 should be equals to minus 42 by 10. Chuskondi. I1 is 42 by 10 and 21 by 5. Same values ra. Same values. Understanding whatever current has been coming, it has been distributed in two parts. Next. What is left? ACL completed. Okay. I'll give you a few more questions. Dan tarvata we can directly jump to another topics. Okay. Hey, not like this, right? Okay, it should go. It should also have like this. Take random values, okay? Let us say 2 ohm, it is also 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 2 ohm. Okay, 4 volt, 6 volt, 10 volt. Cheppandi ra. Okay, current through each resistance naku kavali. Or, yeah, same question. Cheppandi andariki. I want the current through each resistor, okay? Let us try to see it. Okay. Okay. You do it, okay? You do it. Let us talk about PYQs, Ra. Okay? So I'm writing the PYQs. A wire of resistance, eh? A wire of resistance R from this two equivalent resistances are made. The net effective resistance of the combination. Yeah. Pretty fine. చెప్పండి. So, sir, the question is telling, I have a wire of length L. Example, length is L, resistance is R. I am cutting it into 8 different parts. 8 different parts in Telugu. 8 different parts in the sense. Cutting it in 8 parts. 1. Not equal to. Okay, anyways, చూసుకోండి రా 1, 2, 3, 4, 5, 6, 7, 8. 8 parts. అదే కదా? What is the value of resistance? R is equals to rho L by A. గుర్తుందా? Rho L by A. అంటే R is equals to rho into L by A. If the length is decreased, resistance also decreases. 8 parts అంటే the length is R by 8. చూసుకోండి, ఎక్కడ కూడా R by 8. అందరికి R by 8 కదా? So resistance also decreases. All resistances are R by 8 only. So what they do now? They take 1, 2, 3, 4 and apply them in parallel. This. And again for the next remaining 4, they take 1, 2, 3, 4. They take in parallel. Ade kada? Yes. So these are the 8. Now they connect this in series. Chooskondi. So this first, second, third, fourth resistor, fifth, sixth, seventh, eighth. Every value is R by 8, 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 R by. What did I say? Kurtunda? Combination of resistance in parallel, if all are equal, 2 resistors are there, R by 2, 3 are there, R by 3, 4 are there, R by 4, 4 are there. Every resistance divided by 4. So net resistance R net is equals to divided by 4 ante kada. Each value is how much re? R by 8 ante R by 32 is this. Here also R by 32 add cheskondi series lo untundi kada. So you simply say sir R by 32 plus R by 32 ante R by 16 ade. Next, I don't know if I should go with these questions or not, but I'm doing it. Same format are there. Our format is almost the same. Let us move with our syllabus. Then let us see if possible. We'll keep going. KCL completed, right? Hello. Good, Ram, very good. Okay, very good. Now, let us talk about Wheatstone bridge. Before that, let us discuss some questions. Okay, some questions. I want to give you a few questions. Choose one. Question this one. Question is, R చెప్పండి. Next, question number 2, Ra. This is my circular path. Hey, not like this, right? Okay, so this is my circular. Why is it not getting completed? So this is me. So this is my circular path. Let us do one thing. I'm giving a cut this direction, not like this. Right? So I think I should give it cut something like this and something like this. Okay, sir, got it. First resistance, second resistance. Okay. Third resistance. Okay, next, third question. Okay, third. దీంట్లో I'm giving you third question. చూసుకోండి అందరికి. So, I give it, I think I should give something like this. I'm making some random questions, okay? Yeah, all of these are random questions. Andari, చూసుకోండి. So here, simply say it's joined to this, right? Yes. So let us take one batch here. And then let us take fourth one. Okay, very easy questions are there. I'm not keeping the difficulty level that much difficult. చెప్పండి. I'll give you 5 minutes time. దీంట్లో సాల్వ్ చేసి చెప్పు అందరికి. Yes, I'm taking 2 classes. Go it. You do it, okay? I'll be back in a while. Done? Not done. You getting it? Not getting it right? Anyone there? Anyone there? Not there. Okay. Let us see. Okay, చూద్దాం అందరి. So to solve this question, you had to assume the points. You had to assume the points. అంటే ఏం points, sir? Sir, the first point is x. చూసుకోండి, the potential at this point be x. Potential at this point be x. It is the method to solve this question. Okay, you can't solve without assuming the potentials. Okay, you can't solve without assuming the potentials. Good. Let us say this point potential is y and ekkada the potential is z. చూసుకోండి, all are linear kada. Yes, so the first point is now point A, దాని తర్వాత immediate point is x, and after that it is y, and after that it is z, and after that it is b. అంతే కదా, చూసుకోండి. Good. Sir, this value r, it is between a and x. చూసుకోండి రా, r. This is the approach, how to solve it. Approach I'm telling you, okay? This resistance r, చెప్పు, it is between x and y kada. Yes, so this is between x and y andariki, right? Yes. Next, sir, this resistance, sir, this is between y and z kada. Yes, so this is between y and z andariki. Cheppandi okasari. Hey, you think this will be valid, ra? You think this will be valid? You think this will be valid? No. It's getting too complicated. You do one thing, Ray, okay? For your syllabus, I'm just telling you. You replace the resistances with the wires. Okay? So you don't take this resistance here, you take simply the wire. Okay? Take the wire. You take this as a wire, and also you take this as a wire only. You know, and then you have to cancel out the resistances, right? Yes, we'll do it. We'll do this type of question. Okasari, let us complete the wheatstone bridge. After that, I'll take this sort of questions. Okay? Don't worry. Cheppu. So once our wheatstone bridge is completed, I'll take exact this type of question. Okay. How to wipe it? Yes, I'm wiping it. I'm wiping it out also. Okay. So this is also gone. Chuskandi. Cheppandi. Now these are wires kada. So if they are wires, and the potential at this point and the potential at this point becomes same. So if the potential is same, ante endira. If the potential is same, that means no current in this branch at all. Are you understanding? Am I doing some mistake, Ray? Again, I think I should not give you these type of questions. So let us do one thing, Ra. Again, let us do one thing. Remove this part also. Cheppandi. Okay. Finished. So, sir, between these 2 points, potential is same and no current is flowing into it. That means you can simply remove these 2 resistances, Ra. You can simply remove these 2 resistances. This is R, and 2R is the net resistance in this scenario. Okay? Net resistance is equals to 2R. Next, come here, cheppandi. Between A and B, I gave an extra resistance. See, this resistance is there, kada, and it is not connected until like this. So, sir, the ends of this resistor, the ends, this same potential on entire round is same, and this end and this end are at same potential. That means there will be no current in that resistor. If the current is not there, remove it. Ante kada. If the current is not there, remove it. Okay, remove it. How will you remove it? It removed. It's removed, completely gone. Ante kada. Yes. Now you're only left with these resistances. 1, 2, 3. చూసుకోండి, it was point A and this is point B కదా. So ఇక్కడ point B ఉంటే here is also point B. Everywhere on this ring the potential is B. అంతే కదా. Yes. So sir, you consider 2 points. First point is point A. Inkra. Okay. First point is point A. Second point is point B. చూసుకోండి, this resistor it is between A and B. అంటే this resistor is between A and B, R value రా. Cheppandi. Here also, this resistance is also between A and B kada. Yes, so this is also in between A and B ra. Value is R. And this ray, it is also between A and B. And this is also between A and B. And R are in parallel. Same values, same resistances, they are in parallel. And divide by 3. Finished. Sir, net resistance R net is equals to R by 3. Ade kada. Gone. Next తీసుకోండి. This one. Point A is here, B is here. Again, I'm telling you, you see, if the potential at this point is B, it's a wire. Wire unte, potential here also B. Sir, if it's a wire, here also potential is B. Sir, అదే కదా? Yes. చెప్పండి, ఇప్పుడు చెప్పండి, all of you. See, this R and R, this R and R, they are in series. Series అంటే this will become 2R రా. అదే కదా? Yes. So series లో ఉంటే the net resistance between this becomes 2R. 2R, R. They are all in parallel రా. How parallel? Check the ends, okay? Okay, check the ends of a resistor. Check the ends of a resistor. Ante entira? Check the ends of a resistor. This is our first resistor. This is my second resistor. Okay? This is my second resistor. Ante kada? Yes. Sir, this 2R is between A and B. Ante ide na point A and here is my point B. What is the value of resistance re? 2R. Cheppu. Here also. This is point A, this is point B. R. Between A and B, R is the resistance. This one, right? A and B, R is the resistance. So this is the resistance, ante kada? R. Here also, A and B points, R resistance. All are in parallel. Now you see, R. Same values kada? Same values ra. Same values ante R by 3. So remove these 3 resistors. Remove these 3 and instead of these 3, write R by 3. Ipudu 2R and R by 3 parallel lo untundi kada? 2 resistances, shortcut formula cheppura, R1 R2 by R1 plus R2 kada? R1 R2 ra, 2R into R by 3 divided by 2R plus R by 3. Ade ante enti ra? Ante 2R square by 3 divided by cheppo 8R by 3. Ante 2R square by 3 divided by 8R by 3 gone, R gone, ante 2R by 8. 2R by 8 kada? Not 8 ray. 7. Sorry, 7. The net resistance is 2R by 7. Gone. Finished. ఇప్పుడు చెప్పండి రా. Hey, this scenario. Voltage V kada, you assume the potential at this point to be 0. It is how we solve it, right? You assume one point to be 0. Whenever a battery and circuits are given, there are multiple options to do it. Either simplify the resistors. Possible. Ledandi ante, you can simply say, what you can say? You can simply say the potential at a given point is 0 and then calculate the circuit. Leda, you assume the potential at a given point as X. You have 3-4 ways, okay? You must be good at all of them. How, Ray? I don't know who are talking to you. Who? You're talking to me or talking to one another? Hey, I don't understand, Ray. Chuskondi. These two are in series. These two are in series. Ante R, 2R, and these 3, this, they are in parallel. So, sir, this is my first resistor. Series ante calculate chesina tarvata 2R value ochindira. Chudandi andariki. This is the second resistance. Middle lo unte it is R only ra. And here extreme resistance cheppandi. R series lo unte 2R. Ikkada kuda kada? Yes. So you have this value. Ippudu you have this resistance R. Ikkada kuda you have the resistance R kada? Yes, you have it R. Chuskondi andariki. This 2R and this 2R are in parallel. So first of all, you have to apply the strategy ra. Same values kada? Same values. 2 resistors are there. Same values for each resistor. So the net resistor becomes 2R by 2 and R. And instead of this resistor, you write only a single resistor of value R. Cheppandi. So this is R. It is gone. This is also gone. Ante kada? Ippudu this R and R are parallel. Same values. Parallel. Same values. Sir, 2 are there. So R by 2. And it becomes R by 2. R by 2 ra. Okay, battery is V only. This becomes R by 2. Ante kada? So this is gone and we will take a single resistance ra. Chuskondi. So the value of that single resistance will be R by 2. Ekkada R, here is R by 2, here is R. Series R, 2R plus R by 2 ante 5R by 2. Net resistance ochindira na daggara. Net resistance is equals to 5R by 2. Voltage is V ante I is equals to V by R ante V by 5R by 2 ante 2V by 5R is the current flowing. Now I want you to bring your attention towards a special topic. Chuskondi. It has been asked multiple times. Okay, it has been asked multiple times. Andariki. Potential is V, okay? Ramu, potential is V only. V only. V only. Okay? V only. Next. Okay, we'll take it. Hey, mysterious. This class will be till 2 p.m. Okay, 2 p.m. Then tarvata we'll take 10-15 minutes break and then we'll again start with work power energy. Sir, mottam day pack ra. Yes. Okay. Now, let us see about this question. Andarki chudandi. So this is a resistance split into 2 parts kada? Yes. Or I should just not give you this value. Let it be. Okay, let it be. Cheppandi. Okay. What should I give the values? Let us say 2 ohm is the value. Let us say here is the 7 ohm. Ante kada? General values తీసుకున్నారు. General. And 14 by 9. Let us say 28 volt is the battery. Ante kada? First of all, I have to calculate the total current in the circuit. Question number 1. Question number 1. Calculate total current in the circuit. Number 1. Question number 1. Calculate the total current in the circuit. Ante first we will have to take the net resistance. Ante kada? Sir, these 2 and 7. So rendu resistors unnayra. Take direct formula. What is the direct formula, sir? Sir, R net is equals to, simply equals to R1 into R2 divided by R1 plus R2. Ade kada? Yes. So, idi me shortcut formula for 2 resistances. Cheppandi, R1, R2 ante 40, R1 plus R2 ante 9. So, ide na equivalent resistance. Ante kada? Yes. So, sir, instead of these 2 resistor, I can write only one resistor of 14 by 9 ohm. Ippudu talk about current. Current is equals to V by R net. Ante kada? Voltage entara? 28. R net entara? 14 by 9. Ante you can simply say 28 into 9 by 14 ante 18 ampere of current is flowing. Understand? Eppudu we will see how is it flowing. Okay, where and how is it going. Chudandi andariki. So ide na 18 ampere current, it started from the positive terminal. Ante kada? So 18 started from here, going up, going towards the right. So it is 18 ampere current. Andariki chudandi. So here also 18 ampere of current is there. What will happen? Okasari it crosses this point, right? It will get distributed in 2 currents kada? I1 and I2. Andariki cheppandi. Right? Yes. Sir, what is the value of I1 and I2? Naku I1 and I2 kavali ra. Cheppandi. Okay. I want the value of I1 and I2. Andariki. Cheppu. What do you think will be the value of I1 and I2? What do you think will be the value of I1 and I2? What is the value of I1 and I2 value? Ra? Cheppandi. To find this I1 and I2 value, sir, we can use some tools. Am tools ra? Tool number 1, you understand. Okay, tool number 1, you understand. Hey, be with me, be with me. Tool number 1, you understand. This 18 ampere current is getting distributed in I1 and I2 kada. So what can I write? Can I simply write, sir, 18 is nothing but I1 plus I2. Ade. Are you understanding? Are you understanding? 18 ante na total current ra. I. So sir, 18 ante na total current I is equals to I1 plus I2. It is my first equation ra. Andariki ardham cheskondi. This is my first equation. Tarvata, I will see the potential differences. Okay, so if you assume potential at 0 here, ekkada kuda 0 vastundi. 0, 0, 0. 28 volt battery kada, so directly jump cheskondi. This is also 28, ekkada kuda 28, 28, 28, 28. Ante kada? Right. Ante potential differences are the same. Andariki ardham cheskondi. Potential differences are the same. Ante what can you understand, re? Current, చూసుకోండి. I1 is flowing in this branch kada, and I2 is flowing in this branch. అందరికి చూసుకోండి. Let us say the value of the resistance is R1. Let us say the value of the resistor is R2. R1 and R2 are the values. అంతే కదా? Hey, potential is same, re. Potential formula. V is equals to IR. IR. Yes, sir, I1 into R1 should be equals to I2 into R2. Ante kada. I1 into R1 is equals to I2 into R2. Equation number 2. So, what can I write? Sir, R1 in multiplication, send their division, sir, I1 is equals to I2 into R2 by R1. Ade kada? Yes. You put this value of I1 into this equation. Andariki. I'm going to tell you the shortcut at the end of the day, but I'm telling you the proof of all of it. Okay? So now real equation is I is equals to I1 plus I2. Dan tarvata, the second equation that I got is I1 is equals to I2 into R2 divided by R1. You lift this I1 value, put it there. Sir, I is equals to I2 into R1 by R2 plus I2. Ade kada? Cheppu. I2 take you take I2 common ra. Cheppandi. So sir, 1 plus R2, sorry, R2 by R1 ra. Sir, 1 plus R2 by R1 plus, not plus, into I2. Into I2 is equals to I. And I is equals to R1 plus R2 divided by R1 into I2. Multiplication lo untundi kada, idi mottam. You send it here in division. Cheppandi andariki. So I2 is equals to, sir, R1 divided by R1 plus R2 multiplied by total current I. Symmetry ra, symmetry. Similarly, I can write I1 is equals to, for I2 it was R1. For I1 it will be R2 kada. Yes, so R2 divided by R1 plus R2 into I. Ade. So this is the formula for I1 and I2. Direct formulas good petkondi. If you are understanding, remember the direct formulas. Okay? If you are understanding, remember the direct formulas. So sir, na daggara branches unte, how the current is gonna change, sir? So let us say, cheppandi andariki. So if this is 3 ohm resistance, if it is 6 ohm resistance, andariki. Okay, 3 and 6 are standard values. I told you, okay, the resistance becomes 2 ra. Parallel lo unte, the resistance becomes 2. So let us say 4 volt is the battery ra. Resistance 2 ochindi kada? Yes. Battery is 4 volt. 4 by 2 is 2 ampere of net current. Andariki chooskondi. This is 2 ampere of current flowing into the circuit. It is going to the left. 2 ampere of current. It is distributing in I1 and I2 ra. Formula cheppu. I1 is equals to R2 divided by R1 plus R2 into I net ra. I net value enta ochindi 2. 2. R2 value cheppu. Idi I1 kada, so it will become R1. It is I2, so it will become R2 ra. R2 is 6 divided by R1 plus R2. Add cheskora. 3 plus 6 becomes 9. So I1 value ante cheppandi 2 by 3 into 2 ante 4 by 3 ampere. Ade finished. What about I2 ra? I2 gurinchi cheppandi. I2 is equals to R1 divided by R1 plus R2 into net current I. Ante I2 is equals to cheppandi andariki. I2 is equals to R1 value untara 3 divided by 9 into 2 ante 6 by 9 ante 2 by 3. Ade. So this is my I2 value. You do addition of them. I1 plus I2 must be equals to net current. Ante kada I1 value untara 4 by 3 plus I2 value anta ochindira 2 by 3 should be equals to 6 by 3 ante 2 original current. Are you understanding? So you understand the shortcut, all of you, eh? All of you. I want the attention of everybody, okay? I want the attention of everybody. Okay? Good, very good. Ramu, very good. Now, understand, okay? Sir, the current I1 value enta ochindira 4 by 3 ampere. 4 by 3 ampere in this direction. Cheppandi, I2 value enta ochindira 2 by 3. Which is more and which is less, right? Sir, 4 by 3 is more and 2 by 3 is less. Ante, can I say, if resistance is more, current is less. If resistance is less, current is more. Ante, current likes to run on the less resistance path. All of us, right? All of us. You are driving the bike. You have two options, Ray. You have two options. One option is a straight option. The second road has too many speed breakers on it. Which one will you choose? Smooth road. So maximum current will choose the smooth road. Traffic completely full aithe, this empty road with speed breakers will be occupied. Understanding? Understanding. Now I will tell you something known as short circuiting. Chuskondi. Ante enti? If you have 3 resistors, okay? Cheppandi. What is the amount of current through each and every branch? The first way is the mathematical way. What is the mathematical way, Ra? What is the mathematical way? Chuskondi. The mathematical way is to calculate the current through each and every resistances. The logical way, what does the logical way say? Hey, 2 ohm resistance unnadira. Resistance is here also, but here is no resistance. Wire ante entira. Wire ante zero resistance. Ante all the current will try to flow through this wire only, Ra. So that means this will not have any current. I is equals to 0, Ra. Here also I is equals to 0. I is equals to 0. I is equals to 0. Here I value is infinity, Ra. Infinity ante it happens a spark. Telusa, I told you, connect 2 wires of a battery, touch them, spark happens. Same spark, short circuit. It happens in your homes also. It happens in your homes also, short circuit. Have you heard the name, Ra? Huh? Good. Great. Okay. Good. So this is all about that. Let us talk about something known as combination, complex circuits. Complex circuits and question is calculate. Question is calculate the net resistance. Leda, don't calculate the net resistance. Okay, calculate the current through the circuit. Okay, calculate the current through the circuit. How are you going to calculate it, right? Okay, first question I'm giving you here. Teeskondi, okay? So this is my battery. Andariki. Let us say good. Okay, right. Teeskondira. This. Ante kada? Right. Let us say value is 12 ohm, okay? 8 ohm, 4 ohm, 4 ohm, 8 ohm, and 12 volt battery is there. Cheppandi andariki. Current kavali. Naku, I want the current of it. Okay? Current. I want the current of it. Okay? If multiple branches are there, if you have multiple branches, then the current distribution will look something different. Cheppandi. So, sir, to solve this question, again I'm telling you, whenever you have a circuit, you remember, okay, whenever you have a complicated circuit, what are the ways? Point number 1, you simplify the resistances. Okay, you check for this. You simplify resistances. Resistances ante series, parallel lo chesi, if possible you simplify. If you find that resistances are not in series, neither in parallel, for example, second example is question like this. We discussed it, right? We just discussed it. So this is the question, not like this. So let us say this is the question. Can you see these are in series? Ledu. Parallel? Ledu. Now what to do? You apply KCL. Ela apply chestaru? Assume potential at general point to be X. Assume potential at general point. General ante special. I should not say general point, at specific point. At a specific point. as X. So the specific point in this question is junction. Junction ra. Ikkada X pettandi and take a zero potential point. Ade. Zero potential. Leda, if you don't understand, if you are finding that this is also not suitable, then check if it is wheatstone bridge or not. Okay, if it is wheatstone bridge or not, I'll discuss with you wheatstone bridge, everything. Okay, for you these are the only three ways in which a circuit could be solved. Okay, only three ways a circuit could be solved. Ante, are you understanding? Yes, so the direction of flow of current will be from higher to lower potential. Ram, it will start from this higher terminal, go like this. Current and a positive current. I am talking about positive. I discussed in the beginning of the lecture. Electrons are moving in the opposite direction, but current is moving in the. So going like this, splitting into three parts, coming again back, and something like this. So this is the direction of flow of current. Right. Which of them is applicable here? Which of them is applicable? Can you simplify resistances? Choose these two series, all three are parallel. Yes. Until you have to use first method only, okay? First method only. Choose this is 8 plus 4, 12 ohm, Ekkada kuda 4 plus 8 is 12 ohm, Ante kada 12, 12, 12. They are in parallel. Parallel unte same values, same values unte direct divide, divide by how much? 3 branches kada, so divide by 3. So net resistance is 4 ohm. 4 ohm. So R net is equals to 4 ohm. Chappandi, I is equals to V by R. Ante 12 by 4 ante 3 ampere of current is flowing. Ade, finished. Question finished. Okay, within 15 to 20 seconds you can solve this question. If you know all the shortcuts, all the standard results, you can only solve it within 20 seconds. Ade kada. Next. 3 ampere. Very good. Very good. Ramu, very good. Very good. Very good. Okay. Next, let us talk about the same problem. Okay, same question, same question. Okay, same question, but I'm just changing some values. Choose one. So this is the same question. Ante something like this, something like this, something like this, something like this. No. Going straight, straight. Okay, finished. Okay, now I'll tell you the battery looks something like this. I got 12 volts, same values I'm taking, okay? Now, let us take, no, instead of this, I'm just taking a change. What is the change, sir? What is the change? The change is something like this. Cheppandi andariki. So this resistance ray, this is 8. This resistance ray, this is 4. Let us say I'm changing the value. This resistance is 16, this resistance is 8, and this resistance is 10. 10. Cheppandi. Ohms, ohms, 10 ohms, 10 ante 10 ohms ra. I'm wasting time, writing in all these things. Cheppandi andariki. So in that scenario, you understand. Are they in series? This 8 and 4, is it in series? No. Series lo unte, the total current in the first resistance should go to the second resistance. Choose 8 ohm nunchi current ostundi. It is going in 4 also and in another branch also. So it's not in series. Parallel lo nahi. Even they are not in parallel. Why not parallel, sir? Sir, the potential at these 2 points should be equal to the potential at these 2 points, but they are not equal. Choose kodi. So they are not in series, not in parallel also. Choose kodi. So point number 1. You can't say that the resistors are in series. Ante kada. Understand. Simplification of resistance, not possible. Assume potential at specific point as X, another point as 0. We can do it. I know. Naku telusira. We can do it. Kani, third point is Wheatstone bridge. You understand the condition of Wheatstone bridge now. I will tell you, okay? Wheatstone bridge title teeskondira. Wheatstone bridge and it is a specific type of question or circuit in which you have this type of options. Choose Kora. So this is my first resistor, second resistor, okay, third resistor. This is my fourth resistor, and there should be one more resistance following this. Okay, this is a standard case of Wheatstone bridge. Now, you remember the condition. What is the condition? I'm not going into the proof of all of this. Okay, just remember the condition. What is the condition, right? Let us say ఇది R1, ఇక్కడ resistance R2, here it is R3, and ఇక్కడ R4. If the ratios are equal, ratios ante enti ra, left side ki resistance తీసుకోండి R1 by R2. If it is equals to right side resistors ra, ante R3 by R4. Okay, చూసుకోండి. Initially no resistor is series or parallel. Nothing is in series, nothing is in parallel. Okay, but when the ratios are equal, that means the total current that is starting from this branch, చూసుకో. Let us say the total current I is there, broken into I1 and I2 ra. Okay, if the ratios are equal, ante మొత్తం I1 current it will flow from this to this. Ide now I1, and here also the total I2 current flows from this to this. Ante no current is in this branch. No current in this branch ra. Ante enti telusa? Ante this branch is useless. Remove it. Okay, remove it. Remove చేసిన తర్వాత these two series they are to parallel. Finish. Your game is over. Okay, but this is the condition. Okay, R1 by R2 should be equals to R3 by R4. Yes, it follows Wheatstone bridge. There must be a condition, and remember, most of the students confuse Wheatstone bridge with like this. Okay, this is R. Let it be. This R should be perpendicular. This R should be perpendicular to the direction of flow of current. See, the current I is flowing like this, kada? Like this, and R is like this. So it is a Wheatstone bridge. But if you are given this question, if you are given with this question, andarki chudandi. So if this is my condition, right? This is first resistor, second resistor, third resistor, fourth resistor, and finished. And my fifth resistor. It's not Wheatstone. It is not Wheatstone, ra. It's not Wheatstone. You can simply do it by series and parallel. Endukante this resistor, it is in the direction of current. Chuskondi. Current is like this. And this resistor is also like this. Difference chuskondi ra. Okkasari difference chuskondi. This is the difference. Ante kada? Are you understanding it? Not understanding it. You understand the difference, okay? This is the battery. This could be, it's not, it could be a Wheatstone bridge. How are you saying, sir? R1 by R2 should be equals to R3 by R4. Then and only then it will become Wheatstone bridge. Okay, condition gurupettukondi. R1 by R2 should be equals to R3 by R4. Ante kada? Here there is no condition. If it is R1, it is R2, it is R3, it is R4, it is R1, R3 series lo. Similarly, R2, R4 are in series, and this is parallel. Finished. Ante kada? Now let us move to this question. Cheppandi andariki. 8 by 16. Gone. Okay. So this might be seeming a little confusion to you. So let us rotate this whole frame so that you will understand it very carefully. Okay? Very carefully. Something like this. Chuskondira. Ante kada? Now it's a Wheatstone bridge. Right? Yes, it is. Cheppandi. 8 by 4 ante 2. 2 kada? Yes. 8 by 4 is 2 by 1. 16 by 8, it is also 2 by 1 ra. Balanced Wheatstone bridge. Balanced Wheatstone bridge ante you can remove this resistance. Ante kada? Yes, you can remove it. Now I'll make it look as it is. Let us shift it. Initial conditions. Right. Cheppandi andariki. So now 8 and 4 series ra. 8 and 4 series ante it becomes 12. 12 kada? Yes. So it becomes 12, right? 8 and 4 becomes 12. So this is 12. 12 ohm ra. Cheppandi. Here 16 and 8, 24, 24, 24, 24. Finished. Ante kada? Yes. So the battery, not like this, right? Not like this. This 16 and 8 are in series, right? Chuskondi andariki. 16 and 8 are in series. Ante 16 and 8 becomes 24. 24. 24. Okay. So it is 24 ohm. Similarly, cheppandi andariki. Similarly, this 8 and 4 are 12. They are also in series kada? Yes. So 12. Ade. So this is my battery ra. Value entara 12 volt ohm kada? 12 volt battery rate, 12 volt battery, 12 volt. Cheppandi. 24 and 12, they are in parallel. R1, R2 by R1 plus R2, sir. Sir, 24 into 12 divided by 24 plus 12. Ade kada? Simplify. How will you simplify? 24 into 12, 12 into 24 divided by 36. 12 ones are 12, 12 threes are 36. 8. So 8 ohm resistance, 12 volt battery, I is equals to V by R. Ante 4 by 3 by 2 ampere current is flowing. Ante kada? Now you can calculate the current in each branch also. How? Sir, I1 is equals to R2 divided by R1 plus R2 into I net. Right? Gurtunda? I2 is equals to R1 by R1 plus R2 into I net. Ade. Finished. Complete. Good. Okay. Good. Next, Wheatstone bridge is completed. I don't know if I should tell you about unbalanced. It is known as balanced Wheatstone bridge. Okay, if the ratio is following, and Wheatstone bridge is balanced. Unbalanced Wheatstone bridge, how to solve it? You can solve it using Kirchhoff current law, understanding KCL. But I think should just skip that. Unbalanced Wheatstone bridge. I don't think it will be asked to you. I want to talk about an important thing that is known as what is this ray? Ladder network. Andariki. Okay, so I want to talk about ladder network tree. Ladder network ante entira? Ladder network ante you have infinite grids of resistances. They are connected to one another. For example, chuskondi. So this is my first resistor, second resistor. This is my first resistor, second resistor. Ante. Okay. So it keeps on going like this. So resistor, resistor. Okay. Resistor, and goes on up to infinity. Ela solve cheyali. That is the condition. Okay. For example, let us say it's 2 ohm and it is 3 ohm. Ade kada? Yes. 2 ohm and 3 ohm ra. Hey, chudandi ra. So to solve this sort of questions, to solve this type of systems, what to do is you check if the repetitions are happening or not. Okay? Repetitions. And it is 2, 2, 2, 2, 3, 3, 3, 3. Same repetitions kada. So I'll do one thing, Ray. I will cut this circuit from this part. Choose kondi. I will cut this circuit from this part. This part. This is my original circuit kada. Complete. So I'm naming the original circuit is equals to X ra. Choose kondi. I'm naming my original circuit. Ray, ink ray. I don't like this ink at all. You know, this is not visible at all. Okay. Cheppandi. I'm naming this circuit as X ra. Andariki. This total circuit as X. And I'm cutting this circuit from this part. Choose kondi. When I see the circuit, it is also equals to X. It is also equals to X ra. It is also equals to X. Ante enti ra? Ante, I can simply say X is equals to, you understand, okay? So this is 2. Ekkada it is 3. Okay? And this entire value ra, it is X kada? Yes. So now understand. This X and 3 are parallel. This X and 3 are in parallel. And this total is in series with this 2 ra. So this X and 3 are in parallel. I'll tell you something like this. Okay. Choose. So here, whatever is coming, resistance, okay, it's a resistance kada, it's a resistance. Same x value, ante kada, choose. This x and 3, parallel, cheppo. Net resistance cheppora. Sir, R1 R2 by R1 plus R2, right? Parallel ante R1 R2 divided by R1 plus R2. Okay. So this is my net resistance. So instead of these two resistance, you can simply say x is equals to now 2 plus this new resistance 3x divided by 3 plus x. Ade kada? Yes. So sir, x is equals to 2 plus all this. So you can simply say, sir, x is equals to 2 plus 3x divided by 3 plus x. Understanding? So x is equals to cross multiply తీసుకోండి. So it becomes 6 plus 2x plus 3x divided by 3 plus x. Right? Send it there. Simplify. Okay, so it becomes 3x plus x squared is equals to 5x plus 6. Ante kada? You send everything that side. Cheppandi. So it becomes x square minus 2x minus 6 is equals to 0. X is equals to quadratic. Solve cheyandi. Minus b plus or minus under root of b square minus 4ac divided by 2a. It is equals to 2 plus root 28 divided by 2 ante 1 plus root 7. So this is my net resistance. R net ante x value ra 1 plus root 7. Okay? Most of the times these complicated circuits will give you solutions in the form of roots. Okay? In the form of roots. Yeah, easy peasy problem. Trying to be disciplined. Let's take this question as your homework question right now. C is my point A and the C is my point B. You take it as your homework question. Next. What is remaining, Ray? Symmetric circuits are not there. Okay, good. Yes, so now let us talk about Kirchhoff voltage law. What does it say? It simply says you go into a loop, Ray. You go into a loop and come at the same point. Ante the net potential that gain or loss is equals to 0. Ante enti, I'll tell you. Choose. So let us say this is my resistance. Okay, this is a battery. This is also a resistance. Understanding? This is one more battery. Okay, let us say R. Leda, I should say 2 ohm resistance is there, 4 ohm resistance is there. Ante kada? Right. So let us say it's 6 volt battery and it is 4 volt battery. I want to calculate the current in the circuit. Chooskondi. Question is calculate how will I calculate? So for that, start from one place. Start from one place. Start from one place. And let us start from this place. Okay, let us start from this place. Go like this. You can go anti-clockwise also. You can go clockwise also. Because since it's my preference, -2 positive, potential increases until I am simply taking 4 plus 4 minus, let us say the current is I. Okay, the current is I. I. Here also the current is I. Ade kada? Yes. 4 completed. Shift. Resistance always eats potential, decreases the potential. Ante, yeah, Harita, you're saying something. Harita. Plus 4 minus I into R. R value is 2. Ade kada? Again it's -2 plus ra. Again it's -2 plus. So it becomes +6 minus I into 4 is equals to 0. Finished. Choose code. I started from here. 4 minus 2i plus 6 minus 4i came at same point, so it should be equals to 0. This is KVL ra. So you can simply say 4 plus 6 under 10 minus 2i, 4i under 6i is equals to 0. I is equals to 10 by 6 ante 5 by 3 ampere. So this is the value of the current. This is the simple application of the Kirchhoff voltage law. Nice. Let us take few more questions based on this. So I'm giving you 2 circuits. So let us say I have to make the questions. That is the biggest time consuming process, you know. Depend. Find current in each loop. Find the current in each loop. The question states, can I do it using KVL? I can do it. Okay, I can do it using KVL also. But at the same time, andarki chooskondi. Hey, but at the same time, okay. But at the same time, I can also do it using the general point. General point and DNT. Okay, I'll try to do it. First of all, I'll change the reverse polarity. It might create a problem. Okay, so 3 volt. Let us take 3 volt only. But gone. 3 volt battery. Cheppandi andarki. So should I solve in both the ways, ra? You want me to solve in both the ways, Ray? Yeah. My 3, I heard it. Next. So let us say the potential at this point is X. Andariki chudandi ra, chudandi. The potential at this point is X. Now I'm assuming the potential at this point to be 0. So if I'm telling 0, here the potential automatically becomes 6. Here, let us say the potential is Y. Here the potential automatically becomes X minus 3 ra. Here also the potential becomes X minus 3. Ante enti sir? Ante I have 3 different junctions. 1, 2, 3. I will apply Kirchhoff current law here. I will apply Kirchhoff current law here. I will get 2 equations. I will solve them. Lengthy process. Okay, you can do it that way also. But let us talk about KVL, right? KVL ante, let us say the current in this loop is I1. Ekkadochi the current in this loop is I2 ante kada. So the same I2 current is coming down, I2 current is going here, I2 current is coming up. Finished? Ante kada, right. Similarly, same I1 current is going here, same I1 current is going here, same I1 current is going here. Ante kada, right. Cheppandi. Now, in this branch, there are two currents, I1 and I2. I1 left nunchi vastunaru, I2 is coming from right. Ante the net current in this branch is I1 plus I2. Ante kada. Do whatever you want to do. You will get two equations you have to solve. In this case also. Okay, I will tell you how to do it. I will tell you. Cheppandi. So let us go in this loop. Tell me the Kirchhoff voltage law. Start from this point X. I1 current is there kada. I1. So sir, X, the resistor always hits the current. And minus I1 into R. R is 2. Ade kada. Okay. Going down. Negative to positive. Potential increases. Okay. Going to the right. Sir, minus I1 into 2 again. Sir, come up. Kani, in this branch, there is I1 plus I2 current. So that means minus 4 into I1 plus I2 is equals to 0. Hey, understanding it or not? Similarly, in this circuit also, okay? In this circuit also. Cheppandi. Start from this point. Negative to positive. Voltage increases. So plus 3. Come down. Come here. Sir, I2 current. 6 ohm resistance. Current. Resistance always its potential. Ante minus 6 into I2. And again come in this part. This loop. Again, what will you say? Sir, minus 4 into I1 plus I2 is equals to 0. So this is your two equations. You have to solve them. Rendu equations unnai, rendu variables unnai. Solve that. You will get I1 and I2 value. Okay? I'm not going to waste my time in all these things. Next, KVL completed, KCL completed. Ante kada? Right. Now, let us talk about what? Combination of cells. Okay? Internal resistance of a cell. Choose internal resistance of cell. Now I want you to little revise your electrochemistry chapter. Galvanic cells unnai kada. Deentlo you have some chemical reactions. Anode is there, cathode is there. You know, reduction is happening at what? Reduction is happening at cathode. Oxidation is happening at anode. All these things. Not remembering, sir. Don't recall all these things. Okay, don't recall all these things, sir. And we are not liking anything of that. Okay. So let us talk about internal resistance of a cell. And the cell is only doing one single task. You remember, okay? Cell has only a single task. What is the work of cell? Sir, to produce the energy. Produce the energy, not charge. Understand? It's a very basic concept. Okay. Hey. Why is it disturbing so much? Right. Cheppandi andariki. Cell has a single work. What is it? Cell produces energy. Andariki chooskondi. Cell produces energy. Ade kada? Yes. It's a very basic statement. Andariki chooskondi. Sir, if energy is being produced, there is a loss of energy. All the times there is a loss of energy. Endukante it has some internal processes going on kada. The anode and the cathode that is there in the cell, they are also providing some resistance, right? So deentlo some energy is getting lost. So that means it is not possible. It is not possible for us to conserve the total energy. Dikshita, you are saying something. Okay. So what happens is, you imagine a resistance. Okay. You take a cell. Ante. So what we simply say is, sir, V is the voltage of the cell. Voltage. R is the external resistance, sir. Sir, current is equals to V by R. This formula is not valid. The cell itself has some resistance. Chooskondi. The cell, the battery itself has some resistance. Ante, if this is the battery, chooskondi. If this is my cell, there is a small internal resistance R also. Understanding? And you can also write like this. if this is the resistance R, this is my cell and this is the internal resistance. Choosukoni andariki. So this is resistance R, this is the external resistance R. The original voltage of the cell, the original, ante the exact amount of voltage it produced, it is not known as Vira, it is called as epsilon naught. Epsilon or naught ante EMF of the cell. EMF telusa? Electromotive force. Electromotive force is there. EMF. EMF nunchi some internal resistance, it will also consume some voltage. Dan tarvata whatever voltage is remaining, you call it as voltage of the cell. Chusko what I am telling. I hope I am clear in my words. Okay, sir, what is the voltage of a battery? I will define. Voltage is nothing but, cheppandi, voltage is potential difference a battery creates. Okay, a battery creates along the ends of an open circuit. Ante entira? Ante, you imagine, this is my circuit, okay? This is my circuit, choosukoni andariki, all of you. Open circuit kada? Open circuit this is my open circuit. Open circuit. If I am attaching a battery, chusko. If I am attaching a battery, V is the difference that the battery creates only along the edges of the open circuit. Kani, it has produced an EMF of epsilon. EMF is epsilon. Deedlo, some internal resistance is also there kada. So some voltage is also gone in this internal resistance. Choose. And sir, this small resistance and this entire resistance, they are in series. So simplify these resistances. Choose. So you simplify these resistances and let us say the external resistance is capital R. Andariki chooskondi. So that means, sir, the current I that is flowing, it is flowing through capital R also and small r also. Ante these two are in series, not parallel, series. Yes, Ramu, it's there. Okay, so that is the reason why whenever you are talked about internal resistance, then only you consider the internal resistance. Leda, you consider the voltage only. Okay, in the previous problems, we did not talk about EMF. Now I am talking about EMF. So EMF vachinante, internal resistance will also come into the scenario. But in the last all problems, we talked about voltage. Voltage ante, this whole process has been completed. Voltage ante the only potential difference that is there across the ends of a open circuit. Okay. Internal resistance only matters when EMF of the battery is given. When it is voltage, then internal resistance will not come. Okay? Good. Sir, this R and R in series. Ante total resistance is equals to R plus R. Chooskondi. Ante kada? Hey, understand. All of you understand. Okay, all of you understand. The current is flowing like this. I. Here also the current is flowing like this kada. You talk about these 2 points, all of you. You talk about these 2 points. So assume the potential is 0. Potential is 0. Ekkada vachi the potential is V kada? Yes. Cheppandi all of you. Come through the loop. So I is there, R is there. Sir, minus I into R, negative to positive. Increase in potential, EMF is equals to V. So ante V is equals to EMF minus I into R. So this is my formula, okay? This is my formula for voltage. So if EMF is given, you subtract I into R, you will get V. In all the previous problems we discussed, we talked only about V. We did not talk about EMF. Okay? That is the reason why all the questions are valid. Understanding? Now, total resistance is R plus R. Ante I is equals to total voltage, total EMF, antara, divided by R plus R. Ade kada? So this is the value of current. Lift, shift. What do you get? Sir, V is equals to EMF minus I value ante E by R plus R into R. Ade kada? Take E common. Cheppandi. So it comes out to be all these things, right? Okay. So R plus R minus R divided by R plus R. Ade. So V is equals to E into R by R plus R. So this is the relationship between voltage and EMF of a battery. Okay. Next, combinations of cells. Give me 5 minutes. Okay, I'll be back. I need to get some water. Okay. After that, we'll discuss combinations of cells. Right. Okay. Yes. Hey, where is the pen, right? Yes, the pen is there. Okay. So let us talk about combinations of batteries. Last topic. దాని తర్వాత possible, it's too right. I don't think it's possible to discuss the few things. I was thinking about to take PYQs. I don't think PYQs will be possible in this session. Anyway, we have work power energy, right? Just after this session. All right. So let us talk about combination of batteries. Hey, when I'm telling combination of batteries, the internal resistance of the batteries is included. Okay. Okay. Yes. So when I'm telling combinations of batteries, ante the internal resistance of the batteries is included. Good. Yes. What are you saying? Okay. Number one, the batteries are in series. Series ante telusa? Series ante enti, sir? I have actually discussed this formula long ago. Okay, long ago. I have discussed this formula long ago. If you remember, you try to remember, okay? You try to remember. In this lecture only I have discussed this formula long ago. Ante entira? Ante enti? Shortcut telusa? KCL lo when we were talking about branches. Branches ante sir, this was the battery. EMF, this internal resistance. This EMF, this internal resistance. This EMF, this internal resistance. This EMF, this internal resistance, and all these things. Keep on going. EMF E1, E2, E3, E4, R1, R2, R3, R4. Ade kada? Yes. So that means you could literally replace this system with a net EMF ra. Chuskondi. With a net EMF and with a net internal resistance RN EMF EN. Ade kada? Right. How sir? How did we do it? Let us say the current flowing is I ra. Let us say the current flowing is I. Cheppandi. What you are doing now is you are trying to calculate the potential difference between the 2 points. You remember I told I was doing something like this. These arrows at each and every point we used to calculate the potential differences. I did it. Okay. You don't remember I did it. In the session only I did it. Okay. You are sleeping. You are sleeping at that time. Chuskondi. So you can simply say these batteries have same terminals అంటే positive negative. అదే కదా? You add them. అంటే E net is equals to E1 plus E2 plus E3 and so on up to En. And similarly R net, they are also in series kada? R1, R2, R3 series la. So అంటే R1 plus R2 plus R3 plus so on up to Rn. Ide. So you can replace it in this way, or leda you understand your first EMF is this, your second EMF is this, internal resistance, third EMF, internal resistance, fourth EMF, internal resistance, and so on and so forth. Chuskondi. Now, when you have to replace it, you replace it. Okay, you replace it. E net, idena R net kada? Cheppandira. It is E1, E2, E3, E4, R1, R2, R3, R4, so on and so forth. Cheppandi. So, sir, E net is equals to E1 positive, yes. Minus E2 negative, yes. Plus E3 positive, yes. Minus E4 negative, yes. How am I telling positive and negative, right? It depends on your assumption of the battery direction. Chuskondi. Okay? It depends on the assumption of your net battery direction. If it is like this, then similar will be positive, opposite will be negative. Something like this. Ante kada? And plus or minus whatever it is. Kani, it is not there with R. R1 is simply equals to R1 plus R2 plus R3 plus R4 plus so on so forth. Ade kada? Yes. Right. Perfect. Next. Chuskondi. Combination of batteries in parallel. Ante kada? Right. Your work power energy, we will start it from 2:30 p.m. Okay, perfect. So combinations of batteries in parallel and entira. Okay. I can teach non-stop for one complete day also. You don't worry. I need good students only, okay, who can focus. And next, Cheppandi. Combinations of batteries in parallel. Sir, if I have batteries in parallel, this is E1 R1. Sir, this is E2 R2. Ekkadochi E3 R3. E4 R4. Noise. I'll tell you direct shortcut, okay? I'll tell you direct formula. Because if I tell you to prove, your brain will it's already tired, I believe. Okay, it's been more than 4 hours we are taking the class, okay? Right. You understand. E value E1, E to E అంటే EMF, ఓకే, EM అంటే EMF, E4, R1, R2, R3, R4 and so on so forth. చెప్పండి. E net is equals to, చెప్పండి all of you, E1 by R1 plus E2 by R2 plus E3 by R3 plus so on so on so. E net by R net, అంతే కదా, whole divided by, ఇప్పుడు you add all of it, right? You add all of it, చెప్పండి. What is it, sir? 1 by R1 plus 1 by R2 plus 1 by R3 and so on so forth, 1 by Rn, అదే కదా, right? So this is your E net value రా. ఇప్పుడు R net రా, 1 by R net is equals to parallel ఉంది కదా, in parallel you take reverse and add it, 1 by R1 plus 1 by R2 plus 1 by R3 plus so on so forth, 1 by R net. You remember these formulas only ra. So where is our formula sheet? Hey, I forgot about the formula sheet ra. Ekkada unnara formula sheet? Where is the formula sheet ra? Hey, where is the sheet, Ray? Hey, here is it. Yes, here is the formula sheet. చూసుకోండి. ఈ ఫార్ములా షీట్ లో you write all the formulas, okay? So now how much formula did we discuss? 10. దాని తర్వాత ఫార్ములా నెంబర్ 11 రా, చూసుకో. కాంబినేషన్ ఆఫ్ రెసిస్టర్స్ కదా, yes. Number 1 సిరీస్ రా. సిరీస్ లో ఉంటే you can simply say, sir, R net is equals to R1 plus R2 plus so on up to Rn. A రా. B తీసుకోండి. B అంటే రెసిస్టెన్సెస్ ఇన్ ప్యారలల్. ప్యారలల్ లో ఉంటే 1 by Rn is equals to 1 by R1 plus 1 by R2 up to 1 by Rn. అదే కదా, రైట్. నెక్స్ట్ క్వశ్చన్, పాయింట్ నెంబర్ 12. What did we discuss, right? We then discuss about KCL. దాని తర్వాత KVL, right? KVL, and after that we talked about EMF of a battery ra. EMF minus I into R is equals to V. R is the internal resistance, ante kada, yes, R is the internal resistance. KCL is not formula, okay? Let us write 13 number formula, okay? So if I have junctions ra, KCL, okay? KCL says your entire current direction should be I1, I2, I3, I4, I5. అదే కదా, yes. Add all of them. Sir, I1 plus I2 plus I3 plus I4 plus I5 plus so on should be equals to 0. It is KCL ra. దాని తర్వాత what did we discuss? We discussed KVL. What does it say? If you have a loop, okay, resistance is there, R1, battery is there, battery is there. Okay, if you have a battery also, so let us say this is the battery, here is your again malli oka battery ra, something like this, okay? The resistance R2 ra, it says turn into loop, ante if current is I, it simply says IR1 minus IR2, IR1 minus IR2 plus V2 minus V1 is equals to 0. You can take whatever you want, okay? Go into the loop. That is the only condition. Next, 14th problem. 15th one ra. 15th one. Combination of batteries. Okay. Number 1, series. Series lo unte, you can simply say E net is equals to E1 plus E2 plus E3 up to so on, En. R net is equals to R1 plus R2 plus R3 up to so on Rn ra. Similarly, B parallel lo unte. So if they are in parallel ra, cheppandi andariki. If they are in parallel, what is it? If they are in parallel, sir, you can simply say if they are in parallel, E net is equals to E1 by R1 plus E2 by R2 plus E3 by R3 up to so on divided by 1 by R1 plus 1 by R2 plus 1 by R3 ra, and so on. Ade kada? Right. Next. How many formulas, right? 15, 16th one. Teeskondi. Formula number 16 ra. If you have splitting resistances ra, okay, choose. Not like this, right? So if you have current I that is flowing, okay, current I is flowing, right? Okay, so if this is current I ra, not working, right? It's not working, sir. If the current is I, here the current is I1, here the current is I2 ra, resistance R1, ekkada resistance R2, you can simply say, sir, I1 is equals to R2 divided by R1 plus R2 into I. Similarly, I2 is equals to R1 divided by R1 plus R2 into I. Next, 17th one is short circuiting. Ante kada? Short circuit. Ante entira? Ante if you have multiple resistors, 1, 2, 3, 4, I1, I2, I3, I4, I1 is equals to 0, I2 is equals to 0, I4 is equals to 0, I3 is infinite. Ante kada? So this is the problem. Finished. What else is remaining here? Okay. How many of you are watching, by the way? Tell me. How many of you are watching this lecture, Andariki? And how many of you are listening in a steady mode, ra? Cheppandi. Now I have to go to the end of the topic, Ray. Huh? Good. Cheppandi. Hey, Last topic now, and then the chapter is completed. Okay. Heat energy. Mostly I'm talking about heat energy. In electrostatics, we had a formula. Right? How many of you remember it? Okay. In electrostatics, if the potential is given by K into Q divided by R, Gurdunda, potential energy is remembered, right? Hey, what is the formula for potential energy? Sir, K, Q1, Q2 divided by R. Ade kada. Ante, what is the relationship between energy and potential? U is equals to Q into V. Ade kada. Yes. Q. U is equals to Q into V. Re. Hey, I want you to remember this relation. Okay, if you are understanding, good. If you are not understanding, sir, energy is equals to Q into V. Ade. Right. So let us imagine I have a resistor. Okay, I have a resistor of resistance R, battery having voltage V, andarki chudandi, V voltage, resistance is R, and the current is flowing is I. Ade kada? Right. Cheppu. Can I simply say, sir, V is equals to I into R? Yes, you can say. Small charge dq that is passing through this resistor. What is the value of small charge dq that is passing through the resistor? Sir, dq is equals to I dt. Ante kada? Yes. So, sir, heat energy is equals to cheppandi small charge dq multiplied by V. Ante kada? Yes, small energy d. Ante V into dq value cheppura I dt. Right. So, sir, it is the value of small energy de. Integrate cheskondi over a long period of time. Andariki. What do you get? What do you get? Sir, integral dE is equals to integral V into I dt. V value entira IR multiplied by I dt. Ade kada? Yes. So I into I become I square. Common. It's a constant quantity. Take it out. So sir, I square R coming out integral dt from 0 to t. Integral dE is 0 to h. So heat produced in the resistor is given as heat is equals to I square into RT. Ade kada? Yes. So this is the heat produced. Now you talk about, hey, where I is a constant, resistance is also a constant. If resistance and I are variable, you have to integrate by putting the values. Okay, you have to integrate by putting the values. Good. In the last case, let us talk about power. Sir, electrical power P is equals to W by T. Ante kada. Power is equals to energy per unit time. So small power P is equals to dE, small change in energy by time. Ante kada. dE by dt ante dE by dt of energy ra. dE by dt of energy antara I square RT kada. Yes. Differentiate cheskondi, you get I square R. This is the electric power ra. V square by R kuda rayochu, I square R also you can write it. Okay? So these are all the topics that you can say were important for your academics. There is one more topic, color coding of resistors. It's a very 2-5 minutes of topic. Okay, if you can cover it by yourself, it's a theoretical topic. You do it. I know you will do it. Okay, right. And then your entire current electricity gets completed. Okay, sure, good. So thank you so much for all attending this class, and I hope this was helpful. Okay, sure, bye. All right. All of you have a very good day, and come to work par energy lesson also. Huh? So 2:30 re. Hey, 2:30. Not 2:30. Let us increase the time. Yeah, thank you so much. Bye, Vivek, bye. Okay, 2:45. Yeah. Let us take at 2:45. Okay, 2:45. Let us take the lecture at 2:45. Okay, Andariki. So have a... Yes. I hope it was helpful. Right. Thank you so much, Ramu. Thank you so much.